All right. Can I see here? Nice. Big. If you are watching this, which I know you're not because there's 0 people in the chat, or I can see how many viewers. But if you're having trouble hearing at any time, please say it in the chat so I can tell that you can't hear me. Because if I can't not hear myself, I'm right here. All right. Oh, good. Yeah. You can see. I'm gonna watch my own stream on my phone first from another account. If you're wondering what I'm doing, eventually I'll edit this video, probably. But started in a couple minutes. Just wait a second. Trig Proofs. Let's go. Filters. Live. Apply. See if it pops up. Oh, look at that. Oh. There's like a 5-second delay. That's fun. All right. Trig. All right. All right. Let's get started. Okay, introduction. Why would I be making a video about trig proofs? 1, so people can learn. 2, because it's a math assignment. Oh boy, grade 12 math. They come out with the cool stuff now. You get the cool projects now. Ooh, notification from a teacher right now. Ooh. So, trig proofs. What are they? Oh, a trig proof is basically you've got, say, some equation like some equation, say sine squared theta minus 1 is equal to negative cos. You get some equation where it's like, oh, they're saying that someone's just telling you that this is equal to this. How do you actually know that it is? You've got to prove that this is, like, you have to prove that these are actually equal to each other. So a trig proof is basically the process and result of proving that, these trig things are equal, they're true. All right. Now how do you do that? Okay. The most important thing about trig proofs is not like regular like algebra, where you can just be like, oh, let's add 1 to both sides. So you get, sine squared is equal to 1 minus cos. No, you can't. Do not do that. You cannot do that. For trig proofs, absolutely no. Do I know why? Kind of. You can mess up. 1, you can mess up what you're trying to do very easily. 2, this can make it not actually, there's lots of reasons why you don't do that. Here's how you actually would prove it. First, you make a table. This helps you separate the sides, that way you don't try and do algebra. So you got your left side and your right side. You write the left side of your equation on the left side of the table and the right side on the right side of the table. Now that you have this, you manipulate it or simplify it such that the left side becomes equal to the right side. Now, for something like this, you're like, oh, well, what do I do? One of the ways you could solve like this one is you would use another identity that has already been proved to be true, say the Pythagorean identity, where sine squared plus cosine squared is equal to 1. Now you can rearrange. So, say you subtract 1 from both sides and cosine from both sides, you get. Okay, never mind. Backtrack. Okay. If you say subtract, just get out of here. Okay. I haven't live streamed before. It's stressful filming things live. Okay. Getting to it. You have some identity that you know is true. You can use this where it's like, sine, you can move cosine over. So sine is equal to 1 minus cosine. And then you can use this to replace parts of your, down here to manipulate it. So, replace sine. Let's go 1 minus cos squared minus 1. Now we have 1, and then we have minus 1. We can simplify this. So negative, these cancel out. You get negative cosine squared theta. And now you say, look, this side, the left side, it's equal to the right side. And that would be proving a trig. That'd be a trig proof. All right. Okay, now to the real ones. Okay, I'm going to be going through about 30 examples here. Not all of these are particularly difficult. Most of them are actually fairly simple, but they're not necessarily short. Some of them might be like 2 steps, it's like, divide everything by a sign and you're done. Or replace everything, you just use this and replace something and boom, divide, you're done. But other times you got to factor, you got to divide, you got to multiply, you got to factor, all these things. When I'm done, if I find that I see one that I think is going to be difficult, I'm going to highlight it, and I'll highlight it when I'm done this, I will also probably highlight the timestamp or something. I don't know how you do a video after you're done live streaming. I'll figure it out. I'm just rambling. You don't need to listen to me right now. Okay. Let's go to the first example. Before I do that, I might write down just the identities. No, I can do that. I can show you as I'm going through. Okay, example number 1. This one takes about 4 steps from what I remember. So, okay. What is the first example? We have secant x divided by cotangent x plus tangent x is equal to sine x. Step number 1, we make the table. All right, left side, we have, secant x over here. We got that. Can you see that? Not very good visibility because of the camera. Yep. There we go. That's still bad. Okay. Cotangent x plus tangent x. Now on this side, we have sine x. Second step, best place, well, not really a step, but where do you start? You got to figure out, like, okay, which side would be easier to start with? Like, which one, well, not easier to start with. Which side is already pretty simple? This one, it is as simple as it could possibly be. So we're not going to do anything to this because you can't really. You could make it more complicated, but why? It's not a good idea to make something more complicated when you're trying to simplify things, really. So we're going to start with the more complicated side over here. Okay, right now you have a bunch of things. You got secant, you got cotangent, tangent. When you have a bunch of the not cosine or sine, it's a good idea to just turn them all, like rewrite them in the terms of cosine and sine. Okay, so secant x, that would be 1 over cosine x. Yeah, you can kind of see that. And then cotangent x, cosine x over sine x. Tan x is sine x over cos x. All right. Now, we have a lot of fractions right now. You don't want a lot of fractions. It's not great. So to get rid of these fractions, one way we can do that, what we're going to do right now, is multiply by what's in the denominator to just get rid of them. Let's... all right. Okay, so for this one, what we have sine x and cosine x in the denominator, so we should multiply by sine x times cosine x. Just that way, if you multiply by sine x, the divide by sine x and multiply by sine x cancel out, so you just have whatever on the top and whatever else you were multiplying by. Same thing over here with the cosine on the bottom. Oh, man. Okay, we are multiplying everything by both the top and the bottom by cosine sine x. Okay, 1 divided by cosine x. If you multiply that by cosine and sine, the cosine on the bottom cancels out, and you're left with sine x. You got cosine over sine, multiplied by sine, and multiply by sine cosine. Sine cancels out. You get cosine squared x. Similar over here, you're just left with sine squared x. I'm not going to go through every single little bit of like how to simplify a fraction because that seems unnecessary, except for if it was a very, very simple proof where there's like 2 steps, because otherwise it would take 5 seconds to solve it. And, you might as well. Okay, look here. Right now we have cosine squared x plus sine squared x. Now, to me, that looks like, I'm just going to take some space over here. Can you see that line? Yeah, you can see that line. This looks a lot like the Pythagorean identity, where is it? Sine squared theta plus cosine squared theta is equal to 1. Oh, you cannot see that at all. Sorry about that. All right. Sine squared theta plus cosine squared theta is equal to 1. You got sine squared theta plus cosine squared. Cosine squared. Backtrack. You got sine squared x plus cosine squared x. So that can be replaced with 1. And now you got sine x divided by 1. Divided by 1, what do you get? Whatever's on the top. All right, and now you see here, oh, look, sine x on the left side, sine x on the right side. The left side is equal to the right side. Woo! Fun. That's our first identity. All right. This one's definitely not on the harder side. I'll get to the harder ones eventually. I think the first particularly difficult one was maybe number 10. No, number 7 was pretty good. All right. You can pause here if you really want to look at it, or it's YouTube. You can pause, you can rewind, you can do whatever you want. All right, second proof. Here we go. Two. Okay, cosine x minus cosecant x over sine x minus secant x is equal to cotangent x. This looks complicated. I think it's a fun one. They're all fun, honestly. Grade 12 math gets fun again. All right, step 1, table. Left, right side, cotangent x, left side, cosine x. Right. Remember to leave yourself enough room if you're doing this, because very quickly you'll realize if you write too close, you'll run into the line. You want to avoid that because, just generally it's not great if you're doing that. Right. Secant x. I shouldn't have to explain why it's not a good idea to write on top of other lines. Sine x minus secant x. All right. Now, this one is pretty simple, but we can rewrite it in terms of cosine and sine just to make it a little bit more clear what we're aiming to get. Okay, cotangent x, that is equal to, what's it? Yeah, it's equal to cosine x divided by sine x. So this is what we're trying to get this to be. Oh, can you see? It's kind of cool. Yeah, there you go. The glare is kind of making it impossible to see. That's fun. All right. Now that this side is as simple as it can get, let's work over here. Okay. Well, one thing that, if any of these were squared, we could possibly use the Pythagorean identity if they had a double angle identity, but none of them are. So one of the best things to do, I think, would be just rewriting these in terms of sine and cosine. Okay, cosine is already cosine, and then you got minus cosecant is equal to 1 over sine. Then sine, that's already sine, so sine x minus, and then secant x is equal to, can you see that? Yeah, you can kind of see that. 1 over cosine x. All right. From here, all right, I'm going to start, just because we have a fraction under a fraction, I think I'm going to start by multiplying by cosine, just to get that out of there. I'm not sure if that's going to work. Yeah. Wait a second, I actually have them written down somewhere. Let me get that out quickly. Never mind, now it's written somewhere down. I wrote it down somewhere weird. Okay, this is live trig proofs. I've done these before, but I forgot how to do them. Fun. Okay, let's multiply by cosine. So cosine squared x minus cosine over sine, all divided by cosine x sine x minus 1. Okay. I'm going to get that sheet out. All right. How you doing? This is one of the reasons why you do things on whiteboards. It's very easy. If you think you're doing it wrong, you can easily go back and undo things. All right. This is why you shouldn't live stream doing math problems. If you forget how to do them, it's very embarrassing. It's taken 20 minutes to do 2 problems. Fun. All right. Where'd that sheet go? Here. All right. If you're wondering why I did choose to live stream it, because my phone doesn't have enough memory for me to record all these and then do it, which is the much preferred way, because then this isn't happening. Okay. All right. I'm going to go back one step. Again, whiteboard. That's why it's good. I'm going to backtrack and try a different method. Another method of getting things off the bottom of a fraction is, well, not really getting them off the bottom, but kind of making them a little easier to work with, is multiplying by the conjugate. The conjugate conjugate is if you have something like a minus b, the conjugate would be a plus b. So when you multiply it, something by its conjugate, you just get the first term squared minus the second term squared. And then on top, something happens. So let's try that instead. Cosine x minus 1 over sine x. Then times sine x plus 1 over cosine x. And then on the bottom, we'd have sine x minus 1 over cosine x times its conjugate, sine x plus 1 over cosine x. All right, what is that? When you expand that, what does it come out to? Okay, cosine x sine x. Then you got 1 over sine x times sine x, you get minus 1. Then cosine x times 1 over cosine x, you get plus 1. Oh, and then 1 over sine x times negative 1 over sine x times 1 over cosine x, you get you get minus 1 over sine x cos x. All divided by sine squared x minus 1 over cosine squared x. Is this the right thing to do? I'm not sure, but look here. Ones cancel out. That's helpful, maybe. I don't think so, actually. This one is actually very annoying. That's fun. Why did I do number 4 to 18, but not 2? Where did... Oh, my goodness. Oh, fun. Where is it? No, it's not. It's not fun. Wrong. I've got to go charge my laptop so it doesn't die. Cool, not. Don't. Oh, no. Don't turn. Oh. Charging. Good. Damn it. Here we go. Back in maybe 2 minutes. You can stop watching. There we go. All right. Laptop not going to die immediately now. Cool. That's fun. Cool problem. I'm going to come back to this one because for some reason I forgot how to do math. Well, that's why we practice Oh, cool. Stick bud. Let's move on to number 3 for now, and we'll come back to this one later. Again, good reason to not live stream trig identities or trig proofs. Okay, number 3. I know for a fact this one is easy because I wrote down that it is, in fact, easy. I wrote easy. Ooh, this one's super easy on my page. All right. 1 over 1 minus sine x is equal to 1 plus sine x over cosine squared x. All right, step 1, table. Okay, we got our table. I think for this, actually, I'm going to go through all the odd number ones first and then come back and do all the even numbered ones. So that way I'm not doing 4 million mostly simple questions before I get to the difficult, but I know how to solve them questions. So let's start. We'll just do 3, then 5, 7, I don't know. All right, getting started with this one. We got on the right side, left side, we have 1 over 1 minus sine x, and then right side, 1 plus sine x over cosine squared x. This one is actually, it's fairly simple, but it shows actually quite a few steps that one might use in solving a trig proof. So it's a pretty good example if you are actually trying to learn how to do these. Okay, on this side, this is already pretty simple. Probably not great to start with this one. You could simplify it, you could manipulate it, but not really any point. Over here, though, we got... Yeah, you can kind of see what's going on there. If it's unclear, this is 1 plus sine, and on the bottom here, cosine squared x. Cosine squared x. You know where you find that? Pythagorean identity. You can replace cosine squared theta or cosine squared x with 1 minus sine squared x. So let's do that now. 1 plus sine x, and then we replace this with 1 minus sine squared x. All right. Now, on the bottom here, you might notice that we have what some call a difference of squares. This can be factored into, start here. This can be factored into 1 plus sine x times 1 minus sine x. And then if you notice here, on the bottom we have one of the factors is 1 plus sine x, and on the top we have 1 plus sine x. So we can divide both the top and bottom by 1 plus sine x to get rid of these, and we're left with 1 over what hasn't been canceled out, which is 1 minus sine x. And now if you look, 1 over 1 minus sine x, 1 over 1 minus sine x. The left side is equal to the right side. So we write that down. Whoa! The trig has been proved. Ooh. All right. I don't know what the problem with the last one was, but this one, pretty simple. Okay, moving on to number 5. Should this be my career? Live streaming math problems? That'd be fun. I could probably make some money off that. Yeah. All right, number 5. Odd numbers. Let's go. Okay, tangent x minus sine x. Oh, this looks fun. Over tangent x times sine x is equal to 1 minus cosine x over sine x. All right. You can see that? Yeah, you can kind of see that. All right. Let's get started. Table. Left side, we have tan x minus sine x over tan x times sine x. And on the right side, we have 1 minus cosine x over sine x. Okay, technically, both of these we can change this one. We can simplify it a bit, but I don't really see any point in doing that. So I'm going to start with this side and just try and make this side equal to this side without changing the side at all. Okay, right now we have sine x, but no cosine x, although we do have tangent x. So I'm going to rewrite tangent in using cosine and sine. All right. This is equal to, tangent is equal to sine x over cosine. Then we have, sine still sine. And again, sine x divided by cosine x multiply, and then sine x, this is now multiplied by sine x. Okay, right now I think the best step would be simplify a little bit. Actually, no, hold that thought. First, we have cosine in the denominator on both the top and bottom. So I'm going to multiply the top and the bottom by cosine to just get that out of there. So sine over cosine times cosine, and you're left with sine. And then sine x times cosine x, you get sine x times cosine x. Then on the bottom, you have sine x divided by cosine x multiplied by sine x, and then now multiplied by cosine x. The cosines cancel out, and you just end up with sine x times sine x, which is equal to sine squared x. So now what can we do? Oh, look at here. We have everything has at least one. Okay. On the top here, we can do a little bit of factoring. fun little factoring. This both right here, this has sine x in it. Over here has sine x in it. We can factor out sine x. So sine x. What is sine x divided by sine x? 1. What's sine x times cosine x divided by sine x? You get cosine x. And on the bottom, still, we can also factor out sine x. You end up with sine x times sine x. This is just different. It's just sine x. Okay, now we have sine x over here and sine x here. We can cancel these out because one's. Oh my god, you can cancel them out. I don't need to say it. I'm gonna keep doing this. I'm gonna spend like 2 hours doing all these, and you can't stop me. You can't. All right, we canceled out this sine x and this sine x. Let's rewrite this to see what we got now. Ooh, look at this. 1 minus cosine x over sine x. Does this look familiar? Well, it does. It's equal to this. So now we can say the left side is equal to the right side. All right, look at that. Third proof number 5, done. Let's get going on to proof number 7. I know for a fact when I watch this video, it doesn't even have to be a long time from now. When I watch this video again, I'm going to be so embarrassed. It's going to be like, ooh, look how cringe I used to be 20 minutes ago. Ooh, fun. All right, example number 7. We're going through, there's no new viewers. We've lost a viewer. If you were a new viewer, we're going through things. We're going through the odd numbers first, and then we'll go through all the even numbered examples. Okay, so left side we have 1 plus tangent squared x over 1 plus cotangent squared x is equal to tangent squared x. Okay, this one should be pretty simple. Before I show the table, I'm just going to write down. Never mind. I'm not going to do that. Table. Here we go. Left side, we have 1 plus tan squared x over 1 plus cotangent squared x. Then right side, tan squared x. This can be rewritten in terms of sine and cosine. Yeah, I'll do that. I don't need to, but I'll do that. Tan is usually equal to sine x over cosine x, but if you square it, now you just got sine squared x over cosine squared x. And I know you cannot see what I'm writing because there's a bright spot right there, and that is awesome. Oh, cool. The only person viewing it is myself. Fun. All right. That's fair, though. I wouldn't... Yeah. All right. 1 plus tangent x. Where have I seen that before? Pythagorean identity. Look at that. Oh, there we go. So we can replace tangent plus 1 plus tan x because that's equivalent to tangent squared plus 1. We can replace that with secant squared x. And then the 1 plus cotangent squared x, what does that look like? 1 plus cotangent squared theta. And what's that equal to? Ooh. Cosecant squared theta. So we can replace 1 plus cotangent squared x with cosecant squared x. Now this we can rewrite in terms of cosine and sine. What do we get? Secant is equal to 1 over cosine, so you get 1 over cosine squared x And then cosecant is 1 over sine. So you'll get 1 over sine squared x. And now when you're dividing by a fraction, it can, you can, when you're dividing by a fraction, it's really like you're dividing by this top number, but multiplying by the bottom number of the fraction. So, actually, ignore what I just said. There's an easier way to explain that. I'm going to multiply both the top and bottom of this by sine squared x. So what do you get? Sine squared x over cosine squared x over 1. And, oh look, it's divided by 1. What can you do? Just get rid of that. Because dividing by 1 is like not dividing at all. And what are you left with? Sine squared x over cosine squared x. Have I seen that before? Yes, I have. Sine squared x over cosine squared x. The left side is equal to the right side. Ooh, fun. If I'm sounding weird, that's because I'm weird. All right. Okay. Number 9. What's number 9? Number 9. We have 1 plus tangent x over 1 plus cotangent x is equal to tan x. Oh, this looks very similar to the last one. Oh, All right. Let's bring out the table. Left side, what do we have? 1 plus tan x over 1 plus cotangent x. Right side, we have tan x. We can't simplify this any further. Well, actually, no, we can. Tan x is equal to sine x over cosine x. But that's the rest we're going to do, so we're not going to do anything more to that side. We're going to work on this side now because it actually has something going on with it. All right. Let's put things in terms of sine and cosine. Is that the right step? Who knows, but you'll find out if it works. That's how you can tell if something's the right step, because it does what it's supposed to do. All right. Plus tan x is equal to sine x over cosine x. 1 is equal to 1. Cotangent is cosine over sine x. Okay, fun. All right. What should I do now? I don't know. Let's figure it out. We can multiply, because there's sine x in the denominator of this fraction here, we can multiply everything by sine x, see if that simplifies things. Let's do that. So 1 times sine x over cos x gets you sine squared x over cosine x. And then 1 again, 1 times sine x plus sine x over cosine x over sine x multiplied by sine x is cosine x. In a second. Never mind. Don't do that. Absolutely don't do that. That you could. You'll solve it eventually, but that's going to take forever. Whiteboard people. It makes it way easier to solve because if you do something wrong, it's gone in seconds. Okay. Instead of doing that, we're only gonna rewrite cotangent. You'll see why in a second. 1 plus tan x, so that's same, and then 1 plus what's cotangent is equivalent to 1 over tan x. Okay. Okay. All right. One second. After this, I'm going to multiply, we have tan x in the denominator. Let's multiply everything by tan. Okay. 1 times tan x, plus tan times tan squared, divided by, 1. You're multiplying by 1 again, you get tan x, then plus, wait a second. I'm not actually going to rewrite this like this. I'm going to keep this just as tan x times 1 plus tan x. You'll see in a second why. Okay. And then plus 1 over tan x multiplied by tan x, you get 1. Now you'll notice something here. You have 1 over 1 plus tan x, and then at the bottom you have tan plus 1x. These are equivalent. And because you're dividing something by itself, you cancel that out. And now this is because this is a factor of this. You cancel them out, now you're just left with tan x. See, I erase that because you don't need to rewrite that in terms of sine and cosine because that's just unnecessary. Okay, well look, we got tan x. Oh, look, we got tan x. Left side is equal to right side. Oh, goodness. 1, 2, 3 steps. I'm going to write that down quickly. No. Where's my pen? What happens if you got 15 pens? You got 10, 15. Number 9. Takes only 3 steps. Pretty simple. Once you figure out how to do it. But you're likely to, if you're like me, you're going to mess it up at least once and then have to solve it again. Okay, number 11. This is going to take 3 hours. Oh my god. It's a lot easier to solve when you're not doing it in front of people. You're going to have to trust me on that because obviously I can't show you because then it'd be hard again. Okay, number 11. This one looks okay. It doesn't look. It looks like a trig proof. That's what it looks like. Yeah. Okay. Tangent x over 1 plus tangent x is equal to sine x over sine of x plus cosine x. Okay. Table, of course. Left side, tangent x over 1 plus tangent x. Then right side, sine x over sine x plus cosine x. Okay, I'm going to start with this one just because I want to. Don't have to. Okay, I'm actually, usually you don't want to. You want to do the opposite of this usually. If you have like two fractions, you want to like add them together or multiply them to, or say you have two fractions that need to be added together, you want to combine them to one. Right now, I'm going to do the opposite. I'm going to take this one fraction and turn it into a fraction plus another fraction. Wait, no, I'm not. No, I'm not. Sorry. Let's go back for a second. Okay. Never mind. Ignore that. Do not. I went crazy there for a second. I'm going to rewrite this in terms of sine and cosine because, yeah, you might as well. Sine tangent x is equal to sine x over cosine x. 1 is equal to 1, and then tangent x is still equal to sine x over cosine x. Oh, look at this. I think there's only going to be one more step left. What is that? Multiply everything by cosine x because it's in the denominator. Okay, what is sine x? We've got sine x divided by cosine x. When you multiply by cosine x, the multiplying and dividing by cosine x cancel out, leave you with sine of x. 1 times cosine x, you got cosine x plus, it's still plus. Then you got, again, you have sine x divided by cosine x multiplied by cosine x. The multiplying and divide cancel out. You got sine x. Where have I seen that before? Perhaps the right side? Let me see. Oh, you can't see it again because of the light. Sine x divided by sine x plus cosine x. Sine x divided by cosine plus sine x. They're the same thing. Left side is equal to our right side. There we go. I'm not the proof expert. I just have a bit of practice. Not all of these will be done very quickly. Number 13. You can probably tell which ones I've done before because they take like 5 seconds to do instead of 5 minutes or 50 minutes. Cool. Like 5 questions in 50 minutes. 6 questions in 50 minutes. Definitely not good, but not particularly bad either. 13. What's that? 3 times tangent x divided by 1 plus tangent squared x is equal to 3 times sine x cosine x. Table. On the left side, I just said we have 3 times tangent x divided by 1 plus tangent squared x. And right side, we have 3 times sine of x times cosine x. Okay. I don't think I'm not going to do anything with this because it's, what would you even do with that? I don't know. I don't think you can do anything with it, and I don't want to do anything with it right now. I'm going to do this because it's more complicated. Okay. Right now I'm seeing 1 plus tangent squared x And I think that reminds me of something. What does it remind me of? Pythagorean identity. Oh, no, wait. Pythagorean identity. Got 1 plus tangent squared x. We can replace that with secant squared x. And the top stays 3 tan x. Now that we have that, I'm going to rewrite this in terms of sine and cosine because we want to end up with sine and cosine. So we get 3 times sine over cosine, all divided by 1, and then secant is equal to 1 over cosine, so secant squared x is 1 over cosine squared x. Now, because we have cosine we have cosine squared in the denominator, so I'm going to multiply everything by cosine squared to get rid of that. So 3 times sine x divided by cosine x. If you multiply that by cosine squared x, you would get, technically speaking, you would start out with 3 times sine x over cosine x divided 3 times sine x cosine squared x divided by cosine x. But because you have you're multiplying by cosine squared and dividing by cosine, you can simplify that to just sine times cosine. And now 1 divided by cosine squared multiplied by cosine squared, you're left with 1. And as I mentioned previously, when you divide by 1, it's like you're not dividing at all. Because multiplying by 1 gets you whatever you multiplied by, and dividing by 1 gets you whatever your numerator was. All right, what do we have here? 3 times sine x times cosine x. This is your left side. What's on the right side? 3 times sine x times cosine x. All right, looks to me like these are the same thing. So left side is equal to right side. All right. We've had 3 steps to solve this one. I'm going to write that down. Moving on to number 15. Number 15, Burger King foot eggs. If you think I'm doing the math wrong, which you don't think because the only viewer right now is me on my other device. Camera too small. Camera too short. Camera too short. Oh, you can't see what I'm doing. You can't see. You can't even see. I'm just a body. Oh. So, but if you did have any problems with what I'm saying, please tell me in the comments. Tell me if you think I'm doing something wrong so I can not do it wrong. Or either I can explain why I'm doing it, or you can correct me if I'm doing something wrong. I would like to know if you spot something like 1 divided by sine is equal to secant. No, it's not. Okay, number 15. Let's go. Sine x plus cosine x all squared is equal to. Oh, wait. I need more space to write this one down. Actually, it's sine x plus cosine x all squared plus sine x minus cosine x all squared is equal to 2. starting off, table, left side. Oh, gonna have to write small for this one. Sine x plus cosine all squared plus sine minus cosine all squared, and then the right side, 2. That's just 2. I'm not going to change 2 because I'm not going to change 2. You can't simplify 2 more than it's just 2. You don't need to do anything to that. So I'm going to start with this side. Okay. This is going to be hard to write out, but I'm going to rewrite my table, redraw my table a little bit, so it's a little easier for you guys to see. So I'm not writing everything really tiny, so you can see. This is the left side, and then the right side. It's just 2. We already know it's just 2. Okay, this. To start off with, I'm just going to expand, get things out of the brackets, so that way we can simplify things. Okay, we have sine x plus cosine x squared, all squared. You're going to get sine squared x plus 2 sine x cosine x plus cosine squared x. Then I'm just going to write this below it. It would be on the same line if you had more space, but I don't. Plus, now we're going to do this, expand this bracket over here, sine x minus cosine x all squared. You're going to get sine squared x minus 2 sine x times cosine x plus cosine squared x. Plus sign there. Okay. If you'll notice here now, we have plus 2 times sine x times cos x, and we have minus 2 times sine x times cosine squared x. Sorry, no, cosine x, not cosine squared x. So you're adding and subtracting the same thing. You can just cancel those out. They don't have to be there. Then you'd be left with sine squared x plus cosine squared x plus sine squared x plus cosine squared x. Now, this reminds me of something. Oh, what is it? The Pythagorean identity again. You got sine squared x plus cosine squared x. You can replace that with 1. Now over here, sine squared x plus cosine squared x. That's also 1. 1 plus 1. Hopefully, 1 plus 1. That's 2. And so now we have left side, 2. Right side, 2. Left side is equal to the right side. That was pretty good. All right. Number 15 takes 1, 2, 3, 4 steps. At the end, I'm going to take look at these, see how many steps it takes to find the average amount of steps per trig, per proof. Steps per proof. Try saying that. It's pretty easy to say, actually. Then I'm going to, using the average steps per proof, I'll find which ones are very simple, which ones are very easy, and, how I can recommend which one of these you should definitely try. And also so I know which one to point out to my teacher in this video, like what timestamp to go to for what part to actually watch, because I'm not going to make my teacher watch a 2 to 3 hour live stream. That'd be ridiculous. I might watch out. I don't think. if you're not my teacher, I've got a good joke for you. I was gonna wait to tell this, but I'm tired. I'll tell you a joke now. We've done a bit of factoring so far, and if you know factoring, you know there's a couple methods of factoring. That's what this is about. What's a worm's favorite method of factoring? Decomposition. Oh, but okay. Number 17. Moving on. Okay. Sine power 4x minus cosine to the power 4x is equal to 2 times sine squared x minus 1. Okay. Table time. Left side, we have sine to the power 4 minus cosine to the power 4. Right side, we have 2 sine squared x minus 1. This technically can be written with the double... actually, I'll just do that right now. If you know your double angle identities, you'll know that 2 times... Okay, cosine of double an angle, in this case double x, can be equal to 1 minus 2x. So, let's wait a second. I'll do that later. I'll do that later. I'll get back to you. Actually, give me a second. Can rewrite this as negative 1 times 1 minus 2 sine squared x. Now, you can do this. I mean, you could technically do that step, but that step makes it very clear what you're doing. Cosine of twice an angle, it can be equal to 1 minus 2 times sine squared of the angle. So, it'll be fine for a while. It'll be fine. I don't want that. So, we got negative 1 times cosine of 2x, because x is our angle here. And this can be, instead of writing 1 times negative 1, you can just say negative cosine 2x. These two steps, you can really just skip to straight this. This is just, if you're not quite sure, or if you just want to make it more clear what you're doing, it is often good to just show exactly what your steps are when you're doing a trig proof. It's helpful, All right. Left side time. Okay. Right now, this is a difference of squares. We got something. It does look like you can see that it's cubed. But if something's cubed, that means it's like squared. So we can rewrite this. We can factor this in as a difference of squares. Bracket number 1, square root of our first term. So you go from sine to the power 4x to sine squared x. Then minus square root of our second term. You get cosine squared x. Second factor, square root of your first term. So you get sine squared x. Then you add plus the square root of your second term. So you get cosine to the power 4x turns into cosine squared x. Kind of ran out of space. Try and avoid running out of space because it looks silly. All right. Now, you got sine squared x plus cosine squared x. What's that? Equal to Pythagorean identity time. Sine squared everything. Sine squared angle plus cosine squared angle. That's equal to 1. So we can rewrite this. And if you're multiplying by 1, it's just gone. This is just gone, really. Because you're multiplying by 1, it's just equal to whatever is not 1. sorry, I'll say it again. You're multiplying by 1. Whenever you multiply by 1, it's just the same number. It's the same value. The value does not change. So you can just immediately rewrite that as sine squared x minus No, I'll do the steps so that way you can see what I'm doing. Sine squared x, this first factor that we didn't change, cosine squared x multiplied by 1. When you multiply by 1, it's just this. So you just got sine squared x minus cosine squared x. Now this, we can go back to our double angle identities. Cosine of twice an angle is equal to cosine squared angle minus sine squared angle. So, again, we got to factor that negative 1 to get there. I should have done that first, sorry. Negative 1 times, you can put the cosine first because it's going to be positive now. Okay, sorry. I'll say that a bit clearer. You got negative cosine. Divided by negative 1, you're getting cosine squared, sorry. Positive sine x divided by negative 1, negative sine squared x. And now, well, I already showed you that's your double angle identity. So you got negative 1 times cosine of 2x. And again, we're going to multiply back by negative 1. So you got negative cosine 2x. All right. Negative cosine 2x. Negative cosine 2x. You can cut out a lot of those steps, but it's better to show them. So, but anyways, left side is equal to the right side. All right. Really, there's only one. I'm going to say that's 4 steps because you don't have to divide by negative 1 and then multiply by negative 1. You don't have to do. That's a little unnecessary. I'll say 4. Around about 4. Because, 1 and then replacing. Yeah, I'll just call it 4. There's probably even you could do it in 3, but I'm going to call it 4. Okay, I like my own stream. 100. Heart. Is that just for the chat? What is that? Yeah. Okay, what's our next question? Number 19. 19 is, okay, that's fun. 1 minus secant squared x. Okay, again, gotta, this one's a long one. You gotta have to write it with give yourself a lot of space. 1 minus secant squared x times 1 minus sine squared x is equal to negative sine squared x. Table. Sorry. The right side. Negative sine squared x. Because you could write. You could do. I'm just gonna keep it like that. Okay, left side. 1 minus secant squared x times 1 minus sine squared x. Okay. You're really only, for this assignment, you're really only supposed to do 1. But who's going to stop me from doing Yeah. I probably should have done one. I've committed though. I've got 75% left of the proofs to do. I've only been doing this for an hour and a quarter. So, okay. We got some stuff that's been squared. You know what that usually means? The Pythagorean identities. Now let's see here. 1 minus secant squared x. One of our identities is tan. I'm just going to write this on the board now because so you can see better. Tan theta plus 1 is equal to secant squared theta. We can kind of rearrange this. So minus secant and tangent from both sides. You get 1 minus secant squared theta is equal to negative tangent squared theta. So we can replace this 1 minus secant squared with negative tan squared. All right, second bracket. What do I see? There's another squared something. And what does that mean? Probably Pythagorean identity. Could also be double angle. No. Just to, if possible, avoid the double angles because they're annoying. I don't like them. Only do them if you're supposed to do a double angle. Okay. Sine squared theta plus cosine squared theta is equal to 1. If you subtract sine from both sides, you get cosine squared theta is equal to 1 minus sine squared theta. 1 minus sine squared x. Replace it with cosine squared x. Cosine squared x. I'm going to erase this bottom bit here so it's not a distraction. Okay. We got negative. We got tan. I'm just going to rewrite that in terms of cosine and sine. It's just a little clearer. We got negative sine. It's tan squared x. Tan squared x is equal to sine squared x over cosine squared x. And cosine squared x is still cosine squared x. Oh, look at that. You're multiplying. You got sine squared x divided by cosine squared x multiplied by cosine squared x. All you're left with, negative sine squared x. Oh, wait, they cancel out. You're left with negative sine squared x. Yippee! I should have a soundboard. I don't want that. I'm not going to do that. All right. Negative sine squared x. Negative sine squared x. Left side equal to right side. Okay. And that took me 1, 2, 3 steps. You may notice here the whiteboard is not attached to a wall. It's propped up by books, specifically, what's a little hold over then? Old French to English Dictionary and a bunch of Warrior Cats books because I've got plenty of those to hold up my whiteboards, of which I've only got one whiteboard, but I've got probably like 40 Warrior Cats books if I really need to use a lot of them. All right. Question 19. Let's move on to 21. Oh boy. Almost done 10 questions here out of almost a third of the way through. Well, I'm almost a third of the way through. You probably haven't watched all of this. You're crazy if you've watched all of this. It's been an hour and 20 minutes. 21. Oh, it took me only 20 minutes to do less. Much quicker in the second half. It's just that question 2 trying to kill me. Okay, question 21. We got cosecant to the power 4 x minus 1 is equal to, oh, wow. It's hard to see. Cosine squared x times 1 plus sine squared x all divided by sine power 4x. Okay. Left side, cosecant power 4x minus 1. Right side, oh, fine, I'm going to write this again. Cosine squared x times 1 plus sine squared x over sine to the power 4x. Okay. What do I want to do with this? Okay. This. Oh, look at this. Something minus something. 1 is equal to 1 squared. So this could be something minus something squared. You got another difference of squares. You can factor this into 2 binomials. Square root of the first term. Let's see that. Cosecant squared x. No bracket yet. Bracket later, or parentheses later. Minus square root of the second term. Second factor. Square root of the first term again. Which is, in this case, the first term square root would be cosecant squared x. And then, okay, continuing. You got square root of the first term plus square root of the second term. So you got end up with cosecant. Your two factors are cosecant squared minus 1, and then cosecant squared plus 1. Okay. What do we have here? Oh, looks like another. We got some stuff squared. Let's see if this matches any of the Pythagorean identities. Oh, it looks like I have so many teeth in the camera. Ooh, icky. Okay. One of these has, it can be rewritten to have cosecant in it. 1 plus cotangent squared theta is equal to cosecant squared theta. Let's subtract both cotangent and cosecant from both sides. That way they can swap sides. You get 1 minus cosecant squared theta is equal to negative tangent squared theta. All right. Wait a second. No, undo that. I'd have to divide again. Subtract 1 from both sides. Cotangent squared theta is equal to cosecant squared theta minus 1. Because 1 minus 1 is equal to 0. And then 0 minus 1 is equal to negative 1. Okay. So right now we have cosecant squared minus 1 is equal to cotangent squared. So, we got cosecant squared x minus 1. We can replace that with tangent squared x in this case. And then other bracket, cosecant squared x plus 1 still. Okay. And we could multiply these right away, but I'm going to rewrite them in terms of sine and cosine just to make it simplifying a little easier. Oh, okay, good. I didn't get marker on my walls. I didn't want that happening. Okay, this is equal to tangent squared is equal to sine squared over cosine squared, and then cosecant squared is equal to 1 over sine squared, and then plus 1 is still equal to plus 1. Now, let's multiply. You got sine squared x divided by cosine squared x multiplied by 1 over sine squared x. This is equivalent to dividing it. This here, multiplying by 1 over sine squared is equivalent to dividing by sine squared. Really, say, okay. Wait a second. So you have sine squared divided by cosine squared divided by sine squared. That you can rewrite that as 1 because the signs cancel out, like the dividing. You got sine on the top, and now you're dividing by sine. Oops, sorry. I'll just write it out for you. Okay. You got sine squared x divided by cosine squared x times sine squared x, because you multiply the tops by the tops and the bottoms by the bottoms. Now you get sine squared x as a factor on both the top and the bottom. You can cancel those out. So now you just got 1 over cosine squared x. All right, and then this plus 1 times this. It's just this. It's plus this. Sine squared x over cosine squared x. Let's add these fractions together. They have the same base, so it's really easy. It's just 1 plus sine squared x over cosine squared x. Okay, not too many steps. Well, that looks like you couldn't get that any more simple, so let's try the other side now. I think this is my favorite so far. Move over here, make it a little easier. Okay. Pythagorean identity time. Okay. No, wait, you don't want that. That'd be stupid. Okay, wait a second. Wait. The steps are road. Okay. I only did up to 18. Right? Okay. Well, this one's pretty fun. Okay, only viewer. Am I still my only viewer? Or is there someone actually watching this now? No. Play. Live, not live. Okay. looks good to me. I feel like this is... I mean, we could simplify it further. Okay, I'm just going to go to the other side. Cosine squared x, 1 plus sine squared x. I'm just going to show you the Pythagorean identity again down here. Sine squared theta plus cosine squared theta is equal to 1. We can move cosine over, and we're left with sine squared is equal to 1 minus cosine squared theta. Now, this will become relevant in a sec because sine to the power 4 x, you can rewrite that as sine squared x times sine squared x. Now, I'm going to replace both of these with 1 minus cosine squared x. So we got cosine squared x times 1 plus sine x all over 1 minus cosine squared x, and that's all squared because there's technically you could also write it as 1 minus cosine squared x times 1 minus cosine squared x, but why would you do that when you could just say squared? I'm sure there's an easier way of doing this one, but this one, kind of silly. It's kind of fun doing it this way. All right. From here, let's try expanding this. Might as well. Oh, second viewer, that's not me. That's fun. Woo! You can just howl like Teen Wolf in the movie Teen Wolf. Okay, cosine squared x times 1 plus sine x. Then we can expand this. If you know how to expand things, but I'll just show it. Okay, 1 times 1 is equal to 1. You've got, if you were to show the expanded form, you would have 1 times negative cos squared x. You'd have 2 of those because you have 2 of those. So you'd end up with negative 2 cosine, 2 times negative 2 cosine squared x, because 1 times cosine squared x is just 1, and you have 2 of them, so it's 2. Plus cosine squared x times cosine squared x, you get cosine to the power 4 x. Okay. Ugh. 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 This one's too fun. Fun in the way that it's going to take forever, and I want to punch this whiteboard because of it. Okay. Let's check my thing, make sure I wrote down that equation right. Oh, fuck. You want? Okay, we're not going to do that. We're going to undo. Oh, yeah. Oh, I tend to go off on a tangent. I just saw that. Perhaps I go off on a sine a sine over cosine. Oh, and yes, the painting's haunted. It's a painting of a cat that is now dead. It watches. It's always watching. And this will probably yes, it will be on the test. If you're doing a test on trig identities will be on the test. Right? Okay. This, don't know. Bad. Don't do what I did. I did it wrong. You shouldn't be learning trig identities, trig proofs from me. Okay, we have, it's hard to, man, you cannot see because of that glare. That is annoying. Okay, you've got, let's point it out. Okay, you got cosine squared x times 1 plus sine squared x. Then all divided by sine to the power 4x. We're going to use that Pythagorean identity, but slightly differently. Sine squared theta plus cosine squared theta is equal to 1. To subtract sine from both sides, you get cosine squared theta is equal to 1 minus sine squared theta. Or sine squared theta. We can replace that cosine squared with 1 minus sine squared. So you get 1 minus sine squared x times, and this stays the same, 1 plus sine squared x, all divided by sine to the power of 4x. Okay. Let's expand that. 1 times 1, 1. You've got 1 times sine x, but you also got 1 times negative sine x. Those end up canceling out, so you don't need to write anything down for that. Then you've got negative sine squared x times positive sine squared x, so you end up with negative sine to the power of 4x. All divided by sine to the power of 4x. You didn't need to do any of this. You did not. Sometimes you do stuff, and it was not necessary. You'd be like, oh, you're erasing all that hard work. Oh, this is why you start with the more complicated side, because sometimes you overcomplicate something that this was simple, but then I made it complicated. Okay. 1 minus sine to the power 4x, all divided by sine to the power 4x. We can split that into 2 fractions. 1 over sine to the power 4x minus sine to the power 4x over sine to the power 4x. Okay, 1 over sine x is equal to cosecant x. So 1 over sine to the power 4x is equal to cosecant to the power 4x. Then minus, you got sine to the power 4x divided by sine to the power 4x. You're dividing something by itself, you end up with 1. What's the right side? Cosecant to the power 4x minus 1. The left side, cosecant to the power 4x minus 1. Left side is equal to right side. And that's the fun thing about trig proofs. Sometimes you do a bunch of stuff, and you didn't need to do that. Did that one take 20 minutes to do? Jeez. Okay, that one. 1, 2, 3, 4 steps. 4 steps, not 40, like I thought it was going to be when I started doing nonsense over here. There's usually a simple, if you keep going, if you're writing more than like 5 steps on both sides, and it's like a high school level proof, it's not supposed to be that complicated, so you might not be, you probably shouldn't do that. If it looks like it's too complicated, you're probably making it too complicated. All right. Let's go. Number 23. Ooh, almost halfway there. And we got left. Got 4 left of the odd numbered ones. And then we got 15 more even numbered ones. Yippee! Okay, 23. Tan squared x minus sine squared x is equal to tan squared x times sine squared x. Let's start with the table. Left side, tangent squared x minus sine squared x. Right side, tangent squared x times sine squared x. All right, for viewers who didn't hear earlier, I've got a great joke about factoring. Doesn't apply here because we're not factoring, but there's a couple methods of factoring. What's a worm's favorite? A worm's favorite method of factoring is decomposition. All right. We got some squares going on here. What does that remind me of? Pythagorean identities. First, I'm not going to do that right now. I'm going to try turning these into terms of sine and cosine. Okay, tangent squared x is equal to sine squared x over cosine squared x. Then, minus, and then sine squared x. It's just sine squared x. Now, we can kind of combine these. We can make these into one fraction by saying, like, oh, that's where you don't need to know this. Sine squared x, that's equivalent to sine squared x times cosine squared x divided by cosine squared x. So now we can, because they have the same base, we can subtract these fractions. Sine squared x minus sine squared x times cosine squared x all over cosine squared x. That's probably a simpler way of doing this. Oh well. Okay. Now on top here, I'm backtracking like this. Never mind. Okay. Sorry, I had a little interruption there. Okay, I'm going to factor out sine squared from the top here. Just, oh, hey. I like trig identities. They're terrible, but also I love them. There's no point. What's silly about trig identities? Or trig proofs? There's no point. It doesn't seem like you just do them, you know? It's just a little silly like that. They're a little goofy. Calculus. I am the person that math is my only skill. Yeah. Hi. All right. Next step. I'm gonna factor out sine squared x. I'm sorry. Hi. I'm gonna factor out sine squared x. Okay, sine squared x outside the brackets. What's sine squared x divided by sine squared x? 1. What's sine squared x times cosine squared x divided by sine squared x? Cosine squared x. And then on the bottom, you got cosine squared x. Where am I going with this? I don't know. All right. Trig identity. Pythagorean identity time. Sine squared theta plus cosine squared theta is equal to 1. We can move cosine over, and you get sine squared theta is equal to 1 minus cosine squared theta. Oh, look, 1 minus cosine squared theta. 1 minus cosine squared theta. You can replace that with sine squared theta. So you got sine squared. You got sine squared x times sine squared x all over cosine squared x. You can simplify that to sine to the power 4x, because sine squared x times sine squared x is equal to sine to the power 4x, all divided by cosine squared x. Now over here we can see that's not equal to that yet. I'm going to erase my identity over here just so you can see it. But we can rewrite in terms of sine and cosine. Tangent is equal to tangent squared x is equal to sine squared x over cosine squared x. And then you got sine squared x, it's still sine squared x. Hi. Okay. So you're multiplying by sine squared x. You can rewrite this as sine to the power 4x, because you're multiplying sine squared x by sine squared x. So you get sine to the power 4x, and that's all divided by cosine squared x. So you got both sides, sine to the power 4x, divided by cosine squared x, on both sides. So left side is equal to right side. Again, a little joke about worms, in case anyone hasn't heard it. This is the third time I've told this joke in this video, or this live stream. There's a couple different methods of factoring. What's a worm's favorite method of factoring? Decomposition. You need to decompose you need to factor a giant polynomial. What do you need? Big worm. You need a big worm. This is how you get good at math. You get a big worm. If you're still watching, friend, I'm sorry I never replied to your Discord message. I tried to send a message and then it didn't go through, and then I was too embarrassed to follow up because I realized after like 2 months that it hadn't actually gone through, and then it was just awkward. So that's kind of, yeah, it's neat that you saw this for no reason. Do you like the big worm? It's like a big version of one of of this little guy here, the magic worm. I'm a big fan of Big Worm, and I hope the world can enjoy Big Worm. It's all math can be solved with Big Worm. Put this down. Oh, I'm so sorry, Big Worm. Okay, let's go. This took 1, 2, 3. Okay, I won't count that step. 1, 2, 3, 4, 5, 6, 7 steps. I solved it in 3 before? What is wrong with me this time? Okay, I'll try solving that one again later because... Goodbye. And I hope you do well. Bye. Recommend it to anyone that you know if you want to. All right, number 25. One viewer again. Still me. Oh, this is one of the proofs of all time. Oh boy. It says here last time solved in 5 or 6 steps depending on how you counted it. Let's see. Cosine plus cosine x plus sine x times tangent x, all divided by sine x times secant x is equal to cosecant x. Oh, fun. One thing that's good to, you can kind of see that. Careful when you're writing secant, your secant x, your SECx. Don't forget the C. Then you're not doing math anymore, you're doing biology. Okay. The table doesn't need to be all that. Enough with my table. Sometimes if your one side is way simple, don't give it as much room on that side because you don't need to. Right side, it's just cosecant x. Left side, however, we need lots of space. Cosine x plus sine x times tan x. I hope I don't run out of marker juice. All divided by sine x secant x. Okay. Better start with the more complicated side, but I'm going to slightly simplify this. Or not simplify, change this. So it's a little more clear what we're looking for. Cosecant x, that's equivalent to 1 over sine x. So I want to end up with just 1 over sine x on this side. Okay. I think a good first step for this, rewrite in terms of sine and cosine. Cos stays the same, then sine stays the same. But now, instead of multiplying by tan, you're multiplying by sine over cosine. Then that's all divided by, sine stays the same. But secant is equivalent to 1 over cosine x. Now I see here, cosine x is in the denominator. We do not want fractions in the denominator. Going to multiply the whole thing by cosine x to get that out of there. Let's go. Cosine x times cosine x. You're going to get cosine squared x. Sine squared x times sine squared x divided by cosine. Oh, sorry, not sine squared x. Sine x times sine x divided by cos x times cos x. The dividing and multiplying by cos x are going to cancel out. You're just left with sine x times sine x, which that's sine squared x. So you got 1 plus sine squared x. Now on the bottom you have sine x times 1 over cosine x multiplied by cosine x. The divided by cosine x and multiplying by cosine x will cancel out and leave you with sine x. Now this looks pretty close to what going here. We only looks like just the top needs to be changed because we already got sine x on the bottom and sine x on the bottom. You want sine x on the bottom, but we want 1 on the top. Now how are we going to get 1 on the top? Take a guess. Pythagorean identity. All right. Sine squared theta is equal to, or plus cosine squared theta is equal to 1. What do we have on the top here? Sine squared x plus cosine squared x. We can replace the top with 1. So we got 1 divided by sine x. What do we have on the left side? 1 over sine x. Right side, 1 over sine x. Those are the same. So left side is equal to right side. 1, 2, 3 steps. We'll mark that down. It took me 5 steps to solve that. I guess he showed his work a bit more. Sorry, Seth. I don't mean to diss you in front of the one viewer that is myself. Okay. Number 27. I was going to show my steps with these colorful markers I got. I spent like $5 on getting these nice colorful markers. I'll probably use them once I get, a webcam or something. So you can. But right now, with the camera quality on just like the webcam that comes with this laptop, here's what you can see when I write with this marker. I'm gonna write cosine. Oh, guess what I'm gonna write? That's cosine x. Can you see cosine x? I can see it on the screen just a little bit, but only that much. So that's a blue marker, green marker. Again, nearly invisible. Black marker. I don't need two. I'm not going to write black and then thin black. That'd be unhelpful. So I just use the big black. I could, if I run out, I can use small black though. You can at least see that one. Then red. It's almost pink. Oh yeah, you just completely cannot see that one. Fun. Like. It's nothing. So that's why I'm not using those. Number 27. Sine x plus cosine x times cotangent x is equal to cosecant x. All right, table. Not going to give very much side on the right because it's literally just cosecant x, which again, we'll do that in a second. Okay, left side, sine of x plus cosine x times cotangent x. Okay, gonna do a little bit of this side. It only takes one step to get it as simple as possible. 1 cosecant x is equal to 1 over sine x. You can't do anything else with that except turn it back into cosecant. But why would you do that? Because you started with cosecant x. All right, over here, I think a good step. Rewrite in terms of sine and cosine. So sine stays the same, cos stays the same, but cotangent, that's equal to cosine x divided by sine of x. What do you have now? You've got sine of x plus cosine squared x over sine of x. Now, sine of x is equivalent to sine squared x over sine of x, because if you divide sine squared x by sine x, you'll just get sine of x. So we can use that to add these two together, because this makes it so that they're two fractions of the same base, so you can easily add these fractions together. So here we still got cosine squared x over sine x. We can now add these together to get sine squared x plus cosine squared x, all divided by sine x, not sine squared x. Now, I'm not going to rewrite it again. It's the Pythagorean identity for the normal one. You got sine squared x plus cosine squared x. You replace that with 1. You got 1 over sine of x. That's your left side. What's on the right side? 1 over sine of x. That left side is equal to the right side. Let's say, I'd say that's 4 steps. There's technically 5 steps the way I did it, but this step, you can go straight to this step. You don't need to show that you're changing it from, I'll say 4 steps, or 5 steps total. Okay, 29, almost halfway through. Then I have to do 2 again. Why was 2 a problem? I don't know. 2 probably has some really obvious way of solving it that I just... Oh boy, I'm going to be up till... Well, at least I'm well prepared for the midterm tomorrow. Okay. 29. 1 minus sine x. This is all multiplied by, in brackets, secant x plus tangent x. And that's equal to 1 over secant x. Table. Right side, 1 over secant x. Left side, one minus sine x, all times secant x plus tangent x. You can do a little bit of this, make it a little simpler. Secant x is equivalent to 1 over cosine x. So if you're dividing 1 by cosine x, you can simplify that to just cosine of x. Now we got to try and get this to just be cosine x. Fun. Okay, how about we write in terms of sine and cosine? 1 minus sine x stays the same, but now you got 1 secant x becomes 1 over cosine x, and then the tan x becomes sine x over cosine x. Okay. Sorry. It's equal to. I'm going to keep this the same for now. 1 minus sine x. But I'm going to add these two fractions together. They have the same base, so it's just 1 plus sine x over cosine of x. Now I will multiply these two brackets together. So you got, really you have 1 minus sine x times 1 plus sine x. That's all over cosine x. So we just got to multiply the top here. We've got 1 multiplied by 1. You've got 1 times sine of x. So you got plus sine of x. You've got 1 times minus sine of x. So you got minus sine of x. And you've got negative sine of x times sine of x. So you get negative sine squared x. Now, you see here, you got sine x and you got negative sine x. You're adding and subtracting the same thing, so you can just cancel those out, which leaves you on the top with just 1 minus sine squared x. Now, that may remind you of something. Pythagorean identity. Literally, most of this is just using the Pythagorean identities. Do this all the time. Just before you do anything else, check to see if this is applicable. Okay, we have negative sine x, so let's try subtracting sine squared x from both sides. You get cosine squared theta is equal to 1 minus sine squared theta. After I do all these, I'll choose a favorite. Okay, so 1 minus sine squared theta, you got up here, you got 1 minus sine squared x, so replace it with cosine squared x. So you got cosine squared x divided by cosine x. Now this can be simplified. You've got cosine squared x divided by cosine x. You just get cosine squared x is equal to cosine x times cosine x. So if you divide it by cosine x, you're left with just cosine of x. What's on the right side? Cosine x. So, I'm going to say 6 steps. Oh, wait. Right, sorry. Left side is equal to right side. Never. That's the important part. That's one of the most important parts. You got to say that. 6 steps. Okay, we're halfway through. I'm going to take a little break. I've been doing trig proofs for 2 hours. Oh, I should not be drinking this with my retainer in. Terrible choice. But I've been making a lot of terrible decisions today. Try the koozie. No free advertising for the beverage. NASA koozie. I also have one of those little ones that look like a jacket or like a sleeping bag or something, but ooh, it smells bad. It smells can't see the breeze from it. It smells like yoga mat. It's fun, but yeah, my shirt looks normal. NASA and no other brand. Okay, wrote down how many steps it takes. After I figure out how to do number 2, I'm going to share this with more people, so. Why is number 2 so... Okay, number 2. Only another 15 proofs to go. What's number 2? Cosine x minus secant x all over sine x minus secant x. And that's all equal to cotangent x. Let's do our table. Right side, just cotangent x. Left side, cosine x minus secant x, all divided by sine x minus secant x. Let's simplify right side just a little bit. Cotangent is equal to cosine over sine. Now let's deal with the annoying side. What do I have to do here? How about oh jeez. Rewrite in terms of sine and cosine. Cosine stays the same. Then minus cosecant becomes 1 over sine x. Sine x on the bottom here stays the same. And then minus sine. So you can see, you can. Oh, cool. My battery's going to die again. I plug that back in so you can actually solve the proof. So I can solve the trig proof and you can actually see me solve the trig. That's why my laptop was further back, because I needed to do that to plug the laptop in. Okay, it'll just be really grainy and hard to see. Fine. Anyways, secant x, that's equivalent to 1 over cosine x. No. I'm not going to do that. No. Not going to do that first. I'm going to try one method where you multiply by the cotangent, or not the cotangent, sorry. What was it called? Oh shit, what was it called? Not the cotangent, no. What was that called? I said it earlier. What was it called? I forgot the word. Okay. Give me a sec. I need to explain this properly, and I can't explain it properly if I forget the word. Sure, glad I live streamed this instead of having to edit together a two-hour video, though. Conjugate. That's the word. The word is conjugate. The conjugate of, say you have, A minus B. The conjugate would be A plus B. And by multiplying by the conjugate, it just kind of, it changes up what's on the bottom here. So, Sometimes you just need to change things, mix things up a little to figure out what you're doing. Okay. So at the top we have cosine x minus cosecant x. That's multiplied by the conjugate of this, sine minus secant, would be sine plus secant. So sine x plus secant x. It's a little hard to see. And then on the bottom we have sine x minus secant x times sine x plus secant x. So on the top here we get every time I do this I feel like I'm just gonna leave that. I'm gonna leave the top like that for now. No, I'm not. Okay. Fine. Ooh, it looks so bad. Ooh, it looks so yucky. Okay. Cosine times sine. Then we have negative cosecant minus sine x. Cosecant is equivalent to 1 over sine x. So when you multiply 1 over sine x by sine x, you get 1. Then we have cosine x times secant x, secant plus secant x. Secant x is equal to 1 over cosine x. So when you multiply that by cosine x, you again get 1. And then you have, negative cosecant times secant. Again, I'm just going to leave it like that for now. Cosecant x times secant x. And now bottom here, we got sine x times sine x. You get sine squared x. Negative secant x times sine x, you get negative secant x sine x. You got sine x, you got sine x times positive secant x, you get plus secant x sine x. And then you got negative secant x times secant x, you get negative secant squared x. You cannot see what I'm writing, but that's fine. I'm describing what I'm saying. Anyways, you got minus 1 and you got plus 1. You're adding and subtracting the same number, so those cancel out. And look down here, you're going minus secant x times sine x plus, and then you got positive secant x times sine x. So you're adding and subtracting the same thing, they cancel out. You're left with cosine x times sine x minus cosecant x times secant x all over sine squared x minus secant squared x. There's gotta be a better way of doing this. This does not look right. That's some way you can know if you're doing it wrong. If it looks like if it's taking forever, you're doing it wrong, probably. Oh, my phone turned off again. No. Okay. That doesn't look so. This looks more complicated than it was before. So that's probably not a good sign. We still went. Alright. Oh, fine. Okay. Okay. Oh my. Okay. This will, yeah, they will get there. Not for why is 2 such a problem for me? Oh wow, someone's here again. Yeah, I'm just taking forever to solve what should be a very. I've definitely solved this one before and had minimal trouble. Let's start again because clearly I have a problem with number 2 for some reason. Okay, oh, he's still here. That's good. Okay, what can we do to this? Right, in terms of sine, cosine. Try that again. I'm not sure if it worked last time, but let's go again. Cosine, same. Cosine x is still cosine x. Negative cosecant x. That's cosecant x is equal to 1 over sine x. Sine x down here stays the same. And then 1 secant x is equal to 1 over cosine x. All right, I'm going to multiply everything. I'll just multiply everything by cosine. See what happens, you know? Sometimes you just gotta see what happens. Okay. Should I multiply by sine too? Now let's just multiply by cosine for now. Okay, cosine times cosine. You're going to end up with cosine squared x. Then you got minus 1 over sine x. Multiply by cosine x, you get cosine x over sine x. Then bottom, sine x times cosine x minus, and then you know 1 minus cosine x times cosine x, you're going to get negative 1. Okay. Backtrack, never mind. Okay. We're going to multiply everything by sine times cosine, because there's also a sine x in the denominator over here. Will this work? Maybe. I don't know. Yeah, we'll figure it out. Cosine times sine. You're going to get sine x times cosine squared x. 1 over sine x times cosine x. The sine x's are going to cancel out. You're going to be left with negative cosine x. This is all over. Okay. Sine x times cosine x. So you're going to get cosine x times sine squared x. Then 1 over cosine x times cosine x times sine is equal to negative sine of x. Why did I do that? That was not helpful. Why would I do? Oh my god. Why did I do that? Sorry, third viewer that went away. It's taking me 15 minutes so far to do this question. Why is this taking so long? Okay. On the top here, I'm going to factor out cosine x. Cosine x. So in brackets, sine x times cosine squared x. Divide that by cosine x, you're going to get sine x times cosine x. Minus cosine x, divide that by cosine x, you're going to get minus 1. Now on the bottom here, I'm going to do the same thing, but I'm going to factor out sine x. Sine x outside the brackets here. Cosine x times sine x squared. Divide that by sine x, you're going to get cosine x times sine x, which is equivalent to sine x times cosine x. I'm just going to write that way because it's a little cleaner. And then minus sine x, you divide that by sine x, what do you get? Minus 1. Now, if you'll see here, if you can actually see what I'm writing, let's cover that up here. This is my previous step. You got cosine times sine x times cos x minus 1. And then down here, you got sine x times cosine x minus 1. You got multiplied by this. You're going to divide by this. Cancel this. You can cancel them out. Why did I find number 2 so hard earlier? What the hell? Okay, because it's canceling those out. Now you're just left with, on top of the bracket, top of here, we got cosine of x. Bottom, sine of x. What was I trying to do earlier? Okay. And then left side, because you got cosine of x, sine of x, cosine of x, sine of x. Left side is equal to on the right side. So number 2, done. Finally. Quick reminder, not alcohol. This is, I just don't want to show the, I don't want to show the logo. No one deserves the free advertising of 2 people who may not just be leaving their phones unlocked to pretend to watch a video without actually, to give views to the video without actually watching it. This company does not deserve those 2 fake viewers' attentions. And if you are a real viewer, still not telling you. This delicious beverage will never be named unless they give me money. I need money. Okay. 1, 2, 3, 4. Only 4 steps. Okay. Write that down. Nothing can stop me from doing Trig Proofs on a whiteboard. Oh, man. Okay. Number 4. Sine x plus don't want to damage this painting. Let's switch this back. Give me a moment. I'm going to put some tissue paper behind this so I don't damage the painting, because it's kind of leaning on the painting a little bit. Sine, cosine, sine, sine. Okay, that should help not damage my painting. Okay, sine x plus cosine x, all divided by secant x plus cosecant x is equal to sine x times cosine x. Table time. Right side, we got sine x times cosine x. Left side, you got sine. Almost. Okay. You got a fraction where sine x plus cosine of x is on the top, and then on the bottom you got secant of x plus cosecant of x. All right. You can't make that any more simple. It's just sine x times cosine x. What are you going to do? Nothing, really. Okay. I'm going to rewrite in terms of sine and cosine. That's usually the best step if there's nothing squared and things are like cosecant or cotangent or secant, because it's easier to see if they're in. It's easier to see what you need to do if they're in sine and cosine. Okay, sine x stays the same, and then cosine x stays the same. Then on the bottom, secant x is equivalent to 1 over cosine x. Then cosecant x is equal to 1 over sine of x. All right, what am I going to do now? Let's multiply everything by cosine times sine. Why? There's both cosine and sine in the denominator, so that's usually a good step to take. All right, sine x times cosine times sine. You're going to get sine squared x times cosine of x. Similarly, cosine of x times cosine of x times sine of x. You're getting cosine squared of x times sine of x. Now this is going to all be over. All right. 1 divided by cosine of x times cosine of x times sine of x. The multiplying and dividing by cosine are going to cancel out and leave you with just sine x. Now, similar, 1 divided by sine x divided by times cosine x. You just got cosine x there. Oh, third viewer, fun. Okay, I gotta keep that attention fast. All right. Would you like to hear a joke about worms and factoring? So there's multiple methods of factoring. You got difference of squares. You got just kind of like the one that you just observe things. Then you got decomposition. And would you believe that a worm's favorite method of factoring is decomposition? It's not a good way of telling the joke. A worm's favorite method of factoring is decomposition. That's the joke. That's it. All right, back to this. Let's see what we can do here. Let's factor out sine x times cosine x from the top. I know I just multiplied the top by cosine times sine x, so it's going to be really easy to do. Get sine x. Actually, I'm just going to go back and show you this step again because it's a little clearer that way. Okay. I'm multiplying this whole thing by sine x times cosine x. So let's start with the bottom, actually. Bottom, 1 divided by cosine x times sine x. The dividing and multiplying by cosine are just going to cancel out, and you're going to be left with sine of x. Now over here, 1 divided by sine x times cosine x. Again, multiplying and dividing, they cancel out. You just got cosine of x. Now on the top here, I'm going to leave this kind of in brackets. So you got sine x plus cosine x. And you might know where we're going with this now. And that what we're multiplying by was sine of x times cosine of x. So we're just going to leave it like that for now. Now, you may notice here, on the top, you're multiplying by sine x plus cosine x on the top, and what you're dividing by is sine x plus cosine x. They cancel out. Yippee! So now all you're left with on the top is sine x times cosine of x. What's the right side? Sine x times cosine x. So left side is equal to right side. Any questions? No? Okay. I'm going to write down how many steps that took. 1, 2, 3. Pretty simple question there. Only 3 steps once you know what you're doing. Now, it might take you a little while a couple more steps and then backtrack and figure out what you are doing though. All right, let's go. Question number 6. For new viewers, I already went through. I've got 30 examples here, and I went through all the odd numbered examples first, and now I'm going through all the even numbered ones because for some reason, when I tried to do number 2 initially, I just couldn't do it. So I just moved on. I just did the odd numbered ones instead of doing 2. All right. Question number 6. One plus cosine of x, all divided by tangent of x plus sine of x. And that is equal to cotangent x. All right. Time for step number 1. We draw our little table so we don't move anything from one side of the equation to the other. On the right side, we have cotangent of x. On the left side, we have this whole thing, 1 plus cosine of x, all divided by tangent of x plus sine of x. Okay. There we go. Now we can slightly change it just to make it more clear what we're trying to do. Cotangent of x is equivalent to cosine of x divided by sine of x. So now that side is all done. You can't simplify. You can't change anything more on that side. Now we know that we need to get this side to equal cosine of x divided by sine of x. What should I do first? What shall I do first? Let's rewrite this in terms of sine and cosine. You got mostly cosine and sine, but you got tan here, which can be rewritten as sine of x divided by cosine of x. So sine of x over here stays the same. Then the 1 plus cosine stays the same. It was really just that one little cosine there that was being a little problem. Okay. Now let's multiply. We got a cosine in the denominator. We got a fraction divided by. We got something divided by a fraction. To make this not a fraction, we can multiply the whole thing by cosine. So I'm going to do that now. 1 times cosine. We got cosine. Positive cosine. You're getting plus cosine squared. On the bottom here, sine divided by cosine times cosine, you're going to get sine. Now over here, you got sine. Sine times cosine. All right. Backtrack, sorry. I'm actually not going to expand this. You don't actually have to do that. It kind of makes things more complicated. Just keep 1 plus cosine in brackets. 1 plus cosine. And then you're multiplying that by cosine. Because you're going to need to factor that out later, most likely. All right, on the bottom here, I'm going to try factoring out sine. So that way, just because. So on the top, let's keep the top the same for now. I'm just going to move the cosine over. So you got cosine in front, so you don't have to write those brackets. You got cosine of x times 1 plus cosine of x. Now on the bottom, factoring out sine, outside the brackets we put sine, then sine x divided by sine of x, we get 1. Then sine of x times cosine of x divided by sine of x, you get cosine of x. Now, if you look here, you'll see on the top and on the bottom, we got 1 plus cosine of x. You know, you're multiplying by 1 plus cosine of x, and you're dividing by 1 plus cosine of x. You can cancel them out. All right. Who is this mysterious third viewer? All right. So now that these are canceled out, all you got on the top is cosine of x. And all you got on the bottom is sine of x. Cosine divided by sine. Cosine divided by sine. Left side is equal to the right side. This was 4 steps. All good? Any questions? No? Okay. Number 8. Don't write on the whiteboard with the pen. Okay. Number 8. 1 divided by secant squared x plus 1 divided by cosecant squared x is equal to 1. Let's draw a table. On the right side, we got 1. On the left side, we got all this. 1 over secant squared x. Oh, no, do that. Plus 1 over cosecant squared x. One, you're not doing, you can't do anything to 1. The right side just has 1. Yeah, you can still blocked. There we go. It's just got 1. You're keeping it as a 1. Don't change the 1 because it's already 1. Now we need to be aggressive, but don't change the 1. This is the only side we're going to work on. We got 2 separate fractions. They're being added. Good thing to do is to combine them into 1 fraction. First, though, actually, no, don't do that. First, 1 divided by, secant x is equivalent to 1 divided by cosine x. So you got 1 divided by 1 divided by cosine squared x. You just got cosine squared x there. Over here, cosecant x is equal to 1 divided by sine x. So 1 divided by sine squared x. You got sine squared x. Okay? And now, where'd my little tab go? I had a second tab open. Where'd it go? Fun. Oh, I had 16 views. Fun. Excellent writing. Okay. Now, you may recognize here. No. list of questions. That there looks a lot like the Pythagorean identity. Sine squared x plus cosine squared x is equal to 1. 1 is equal to 1. Left side is equal to right side. Why does it say I have 3 viewers if I have only have 2 viewers? Don't full screen that. Okay. Chat rate's here. Yeah. Okay, this only takes 2 steps. Pretty simple one. Question number 10. We're going through this, guys. Number 10. Okay. Ugh. Cosine of x divided by secant of x plus 1. Minus 1. This is all, add to this, all of this is cosine of x divided by secant x plus 1. This is equal to 2 times cotangent squared x. Okay, make our table. Left side, cosine x over secant minus 1 plus cosine divided by secant plus 1. Then right side, 2 times cotangent squared x. Cotangent squared x is equal to cosine squared x over sine squared x. So you don't need to do that, but it's a little simple. You can make it a little easier to figure out what you're doing. Let's add these fractions together. You don't want 2 fractions most of the time. You want to get rid of fractions however you can think of getting rid of fractions. Geez. Okay. To add fractions, you got to make it so they have the same base. So I'm going to multiply this whole thing by the top and bottom by this one's base, secant x plus 1. So you got cosine x times secant x plus 1. Now that's all over secant x plus 1 secant times secant x minus 1. Actually, when you multiply, it's a difference in squares right there. So I'm just going to show, without showing the steps, I'm just going to go immediately to, you got secant times secant, you got secant squared. You got negative 1 times positive 1, you got negative 1. And the minus 1 times secant and the plus 1 times secant, they cancel out because you're adding and subtracting the same thing. Now, second fraction, you're multiplying by the base of this one. So you got cosine x times secant x minus 1. This is all divided by the same thing here because, okay. Secant of x, secant squared x minus 1. Now they're all on the same base, so cosine x times secant x plus 1 plus cosecant x secant x minus 1 all divided by secant squared x. Never mind. Keep them separate. Keep them. Do not multiply them. Secant x minus 1 secant x plus 1. Same thing over here. Secant x minus 1 secant plus 1. Oh my goodness. Secant x minus 1 secant x plus 1. Oh, why did I do this? Okay. Now, at the top here, you have cosine x times secant x plus 1, and you got cosine x plus cosine x times secant x minus 1. You can factor out cosine. Wait a second. I am going to expand the top here, both of them. Just make it easier further on. Okay. Cosine x times secant x plus 1. Secant x is equal to 1 divided by cosine x, so you end up with 1 plus cosine x because of the 1 times the cosine. And then over here, cosine times secant minus 1. 1 minus cosine x. And on the back, actually I'm going to just same thing for both of them. Secant x times secant x, you're going to get secant squared. Negative 1 times 1, get negative 1. And then the negative 1 times secant and the positive 1 times secant, they cancel out. So now let's smush these two fractions together. 1 plus cosine of x plus 1 minus cosine of x, all divided by secant squared of x minus 1. Cos x plus cosine x minus cosine x, these cancel out. You got 2 divided by 2 divided by secant squared x minus 1. I did this in 2 steps. What? No, was that? Sorry, that was the next one. It's in 4 or 5 steps. Okay. Okay. Pythagorean identity time. Tan squared theta plus 1 is equal to secant squared theta. Subtract 1 from each side, you get tan squared is equal to secant squared minus 1. So secant squared x minus 1 is equivalent to tan. So we got two divided by tan squared x. I'm actually going to go undo that step there because it's a little unclear the way it's written, but cotangent is equal to 1 divided by tangent. So 2 divided by tan squared x. Left side, 2 divided by tan squared x. Right side, 2 divided by tan squared x. Left side is equal to right side. Alright. Party, party, party. Ooh, look at all these emojis. Ooh. No! I want to watch my own. There we go. Okay. Okay. Number 10 took 5. Ah, it's fell off again. One viewer. Oh, because I'm not watching. Oh. No. Oh, my other viewer left. Oh. Okay. Question 12. Sine squared x divided by 1 minus sine x plus sine x divided by 1 plus sine x is equal to 2 times tangent x, 2 tan squared x. Table. Left side. Sine squared over 1 minus sine x plus sine squared over 1 plus sine x. And then right side, 2 tan squared x. Okay. Let's start with this side because it's a bit more complicated. Fraction on. Wait. 2 fractions. Okay. We want to add these fractions together. To do that, we're going to make them have the same base. We can do that by multiplying one by the base of the other. So this one, the base on both of them will become 1 minus sine squared x, because when you multiply this, the conjugate of this is this one. And when you multiply something by its conjugate, you got the first term squared minus the second term squared. Okay. I'm sorry, can't see the board well. I will. Oh. Yes, move to chat. Okay, I can unplug the laptop now and move it forwards. I think I gotta change my lighting up a bit. Yeah, sorry, I'm filming with laptop camera, so the camera is awful. Man, thank you. Would you say a tie ties an outfit together? I gotta start speaking like Trump. Constantly moving my hands around. Okay, I don't actually have anything written on the top yet. The pen is kind of dying, which is part of the problem, why you can't see. Let's just write those a little bit better. You can't see that one. Better. All right. Slightly better. Okay. Yeah, we're multiplying. So we got sine squared x. We're multiplying by the base of this one, 1 plus sine x. You're going to get sine squared x plus sine cubed x. Then over here, 1 minus sine x times sine squared x. You got sine squared x minus sine cubed x. Now, because they have the same base, we can add these fractions together. Base is still 1 minus sine squared x. Now on the top, we have sine squared x plus sine squared x, so we can say 2 sine squared x. Now we got sine cubed x minus sine cubed x. That simplifies to 0. So you can say plus 0, but why would you say plus 0 when you could write nothing? All right. Now, you'll notice down here, if you know your trig identities, you might recognize the Pythagorean identity. It's sine squared theta plus cosine squared theta is equal to 1. If you subtract sine from both sides, you'll get cosine squared theta is equal to 1 minus sine squared theta. So down here where it says 1 minus sine squared x, you can replace that with cosine squared x. I'll erase this so I have room. So you end up with 2 sine squared x divided by cosine squared x. Now, you're almost there. You got one more thing. Tangent squared tan of x, that's equivalent to sine of x divided by cosine of x. So you can turn 2 tangent squared x into 2 equal to 2 sine squared x over cosine squared x. Ta-da! Left side equal to right side. You write that down. Left side equal to right side. Write down 4 steps. Now I will do 14, unless you can recommend any other identities that you'd prefer to watch me do. Riley, I know you have the list. Dad, who is watching, I know you don't have the list. Put the phone back on. All right. Well, I'll move on to 14 then. So, time to erase all of this again. It's fun. I'm not sure if you can see how long a stream has been going for, but I've been doing this for 3 hours now. So it's all right. Question 14 or proof number 14. Question 14. Secant squared x. Okay, I need more space than that. I wrote too big to start with. Secant squared x minus cosine squared x minus sine squared x is equal to tan squared x. And you can barely see it because of the glare. But that in the middle there, that's cosine squared. I think the rest of it you can kind of see. Okay. Table. Oh, this pen is already dying because of how many proofs I've already done today. Left side, secant squared minus cosine squared minus sine squared. Right side, tan squared. Okay, that looks pretty simple. Let's not touch that for now because it's simple. That you don't want to simplify what is already simple. So let's do this side. Might be good to write in terms of sine. Well, actually, wait, no. Ignore me there for a second. Do not write in terms of sine and cosine yet. Secant will be left alone. Secant squared x. We're going to factor out -1 from these two terms. So you've got -1 times negative cosine squared x divided by -1. You get cosine squared x positive. Then negative sine squared x divided by -1. You get plus sine squared x. Now, Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. So we can replace this with 1. So we're left with just secant squared x minus 1. And now what's that? Another Pythagorean identity. Tan plus tan squared x, tan squared theta plus 1 is equal to secant squared theta. Subtract 1 from each side, you get tan squared theta is equal to secant squared theta minus 1. So you got secant squared theta minus 1 is equal to tan, so you can replace that secant squared x with tan squared x. Tan squared x, left side equal to right side. Oh, it's so smutty looking. You can kind of see what's going on. Riley, if you're... Oh, you're Riley. Riley seems gone. Where is it? Okay, sorry. The number went down. My dad left, I guess. Or wait, no, I left. Whoops. Can you invite other people? Because, I don't know. It's boring doing trig proofs for no one. Well, I guess you're here. But it'd be good to have a third viewer. Yeah. I'm watching my own stream on my phone while doing this. Fast forward. There we go. There we go. Back in my own stream. Let's get number 3 steps. It took me 5 steps to do this before. What is wrong with me? You're doing it wrong if it takes you 5 to 6 steps. You can figure. I thought redoing every trig proof helps find the optimal way of doing it. Fourth person. Ooh. Let's get started writing down number 16. Okay. 1 plus sine of x. Oh, I should have had more space. That won't fit on that line. 1 plus sine of x, all squared, plus cosine squared x is equal to 2 times 1 plus sine of x. I think I remember this one. Table. First step every time. Holy worm. Anyone want to see the big worm? Should I whip out the big worm? What's a worm's favorite method of factoring? Decomposition. I can't stop saying. I've said that 4 times in this stream. Oh, I got the marker. Worm. Only my worm is this big. You may notice, if you can see how long the stream has been going on for, I've been doing trig proofs for over 3 hours now. All I got for it is big worm. Big worm. My worm sure is big. I'll keep the... Let's get a chair for the big worm. I'll get... Big worm has to help do the trig proofs. Yes. No, big worm. There we go. Big worm will stay and help. All right. You also see there's a second smaller worm in the corner. You need more worm? More worm? I've only got a couple more around. Oh, wait, no. Here's a bit more worm. Worm crown. Ah, nope, don't fall over. Worm! I have way more, but they're all in my car, so it would take like 5 minutes to get them. Now I've got 70-ish more, plus the dress, which is about another 100. Worm drive, the worm's only a year old. It doesn't have its license yet. Worm. Illegally, the worm could drive. We gotta figure out if the worm's smart enough to drive first. Do I need more worm still? How much more worm do I need? Can the worm drink? The worm does not have a full digestive tract, so I don't think it would work out very well if it drank. I will get a little bit more worm for you. Not gonna get the car worms because I'll just be leaving you here for several minutes if I got the car worms. But worm hat, some spare worm. Let's see here. Can you see this? No, you can't see it if I put the worms there. No, you can't see the worms if I put them there. What if where do I put the worms? I know. You gotta keep your worm children safe. Worm beard. Worm beard. Worms. Anyways, hopefully this worm beard will help solve the rest of the proof. Yeah, I could pull off a worm Jesus. I should make a worm wig, long-haired worm wig, and then worm Jesus. All right. Trig proof number 16. On the right side, we got 2 times 1 plus sine of x. Could expand that, not going to do that. Left side, you got 1 plus sine x all squared plus cosine squared x. General strategy, worm, and realistically, it's usually step 1, look for, first step 1, table. Second step, look for things that are pretty easy to simplify, like just easy division. Usually that doesn't appear right away, but then look for any identities that you could swap things out with, like the different versions of the Pythagorean identities. Then if there's any like double angle, like sometimes you just gotta do your homework, skill practice, worming it out. Worm. If there's no Pythagorean or double identity, then I'll look for fractions. Like, should I add some fractions together? The multiplying by the conjugate doesn't come off very often, but sometimes it does. Let's see what we have here. Right now, there's no fractions. Oh, you can't see the cotangent. You can't see this. Okay. That made it more white. Okay. You got cosine x there. And over here you got 1 plus sine. This is in brackets. Let's expand to brackets so it's easier to tell what we need to do. Okay. 1 plus sine x all squared. You're going to get 1 plus 2 sine x plus sine squared x. And then this cosine x is still cosine squared x. Now, over here, wait a second. Yeah, sorry. Let's keep this here the same, so 1 plus 2 sine x. Then over here, you'll see sine squared x plus cosine squared x. That's the first Pythagorean identity. You can replace that with 1. And now you see you got 1 plus 2 sine x plus 1. You can combine those ones to get 2 plus 2 sine x. And you can factor out 2 from that to get 2. 1 plus sine x. 2 times 1 plus sine x. 2 times 1 plus sine x. I know you can't really see it, but 2 times 1 plus sine x over there. I'm not giving you my home address. Yeah, right now we're not even doing trigonometry anymore. We're doing trigonometry. I'm not giving my social security. No social security. No social insurance. No home address. No mother's maiden name. None of it. We're doing trigonometry, and that's it. No! No credit card numbers! No! You're only getting credit worm numbers. Too bad I can't commit murder through a screen. I wouldn't do it. All right. Forgot the last step here. Left side equal to right side. I love that my marker's already dying because I've done so many trig proofs. Oh. Okay. That was 4 steps. 4 steps, 4 skins. I'm not giving you my no Google password, no YouTube login. If I had 2 worms and ate 2 worms, would I worm it? Don't eat your worms. That's how you get tapeworms, and those will eat what is in your intestines, and then you'll get sick. Yeah, if it's really that yummy, yeah, get some tapeworms in you. Support platyhelminthes. Stop eating my worms. All right. Any recommendations for Trigs to proof? Raw off the bone. No bone. Got no bone. No boner. No bone. Okay. Option 1, I do number 18. Option 2, you tell me which one to do. And yes, Jesus. Wormesus. I turn water into worm. Yep. Number 18. Got it. Okay. This damn pen, I'm gonna use it. Okay. Tan x minus 1 all squared is equal to secant squared x minus 2 tan x. Oh, well, before I managed to solve this in 2, so let's figure out if I can do that again. Left side, tan x minus 1 all squared, right side, secant squared x minus 2 tan x. Good? Okay, we're good. Expand. Tan times tan, you get tan squared. You got negative 1 times tan, twice. You got minus 2 tan x. Negative 1 times negative 1 plus 1. Now, I'm going to rewrite this slightly differently, where instead of having minus 2 tan in the middle there, I'm going to have my plus 1 over here in the middle. And then over here is my minus 2 tan x. We'll see in a second where you can now use a Pythagorean identity. Yeah! Ah! I'm going to take the worm beer down. Tan squared theta plus 1 is equal to secant squared theta. Room tour. Worm tour. Okay. Tan squared theta plus 1 is equal to secant squared theta, so we can replace tan squared x plus 1 with secant squared x. And then this stays the same, and then minus 2 tan of x. Secant squared x minus 2 tan x. Secant squared x minus 2 tan x. Left side is equal to right side. Trigonometry. Worm plus worm. 2. Should I do number 20? If I give you a room tour, you will know that I have a little bit of a problem with hoarding. So no. Bye, worm. I'm just going to take that off because it's It's more comfortable to wear now that I sewed it back onto it, but it's still very uncomfortable to wear that. All right, number 20, yes or no? Okay, Riley says 20, Lucas says tour. I'm going to do 20. I can maybe do tour after. Okay, I'll give you one little thing. Probably haunted painting of a cat. I got it from my stepmom's mom, or ex-stepmom's mom, Linda's mom. That's a painting of Mickey, their cat, that is now dead. So yeah, I got a painting of someone else's dead cat in my room that it sits over and watches. This painting used to be in a little room in their attic, like a little room with one little bed in it. And now it watches me sleep every night. Watches me sleep and do my homework and live stream Trig Proofs. Yes, it's very good. It's watching you too now. All right, number 20. Number wormy. Cosecant x minus cosecant cubed x is equal to negative cosine squared x over sine cubed x. Ugh. Table. Okay. Left side, we have cosecant x minus cosecant cubed x. Right side, negative cosine squared x minus sine cubed x. Let's factor out cosecant from this. So you'll get cosecant x times 1 minus cosecant squared x. Okay, you're gone now. Don't speak the truth. Okay. 1 Pythagorean identity, 1 plus cotangent squared theta is equal to cosecant squared theta. So if you subtract cosecant and cotangent from both sides, you get 1 minus cosecant squared theta is equal to negative cotangent squared theta. Okay. So we can replace this with negative cotangent theta. So cosecant x times negative cotangent squared x. Now, cotangent x is equal to cosine. So this is equal to cosine divided by sine. So negative cosine squared x is equal to negative cosine squared x divided by sine squared x. And cosecant x is equal to 1 divided by sine x. So when you multiply those together, you get negative cosine squared x divided by 1 over sine divided by times cosine squared divided by sine squared. You get so sine squared times cosine. Sine squared times sine, you get sine cubed on the bottom. Negative cosine squared divided by sine cubed. Negative cosine squared divided by sine cubed. Left side equal to right side. If you got me on other screens, but it's on the same account, same amount of views, I'm. Ooh, let me check something really quick. If you wonder what I'm doing, I'm watching my own thing on my phone. There we go. Live. Okay. Number 22. Fine. Okay. Fine. Pile of things I need to sort. Laundry. Worm. Whiteboard. Haunted cat painting. Bookshelf. Pile of things I need to sort. More nonsense. This is more things I need to sort. Bed I need to make. Pile of stuffed animals that are all like 13 years old. Dresser. Weird art that's all, again, like 13 years old. You may notice Doctor Who themed curtains. Doctor Who blanket. Doctor Who rug. Everything. Because it's all, again, they're all like 5 years old. Because like 5 years ago, I was really into Doctor Who. Yes, very good camera quality. Each pixel is like 2 centimeters. Yet, lots of Doctor Who. I got 2 Doctor Who blankets, 1 Doctor Who carpet, Doctor Who bed sheets, and pillowcase that I don't even use because I don't have a pillow. And then Doctor Who curtains. It's all Doctor Who for some reason. Why did I do that? Doctor Who's a TV show about the alien guy who time travels and his name is the Doctor. But then they go like, Doctor Who! And it's like, haha, that's the name of the show. Number 22. Number 22. Oh, that's a wide one. Tan squared x minus cotangent squared x is equal to sine squared x minus cosine squared x all over sine squared x times cosine squared x. What? I can't vote. Yeah, whatever. Do what you want. I'm just gonna do this. You can do whatever you want. I'm voting for Worm for president 2024 or 2025. 2024. Yeah, it's 2024. Worm for president. Worm for prime minister. Worm for whatever the BC one was. I can't remember what the provincial version of prime minister was. Member of parliament, more like member of Wormlement. Yeah, premier, pre-worm, pre-worm, only worm. Okay, number 22, left side, tan squared x minus cotangent squared x, right side, sine squared x minus cosine squared x, sine squared x, cosine squared x. Conservative worm. You got the conservative worms versus the liberal worms. Werewolf rolls. Oh no. Okay. Sine, cosine, sine, 1.159. I'm going to split this into two fractions. As I know you can barely... Woke worms! Worm... No! People are getting infected by the worm mind virus. Oh, no. Okay. I'm going to split this into two fractions. I could do the opposite and make this one into one fraction, but this is going to be easier. Yeah, it will be easier. Okay. You got sine squared x divided by sine squared x times cosine squared x minus cosine squared x divided by sine squared x times cosine squared x. This sine squared x divided by sine squared x times cosine squared x. You're getting 1 over cosine squared x. Cosine squared x divided by cosine squared x divided by sine squared x. 1 over sine squared x. Worm fraction. Yeah, you can't see what's being written. I gotta scoot the laptop, get all messed up, the angle. Yeah, the camera quality. Oh, it's really terrible camera quality. Let's see here. I'm gonna make that one a bit more visible. Slightly better. Okay. Not gonna do it that way. I don't like that way. I'm gonna make this one more complicated instead of making this one more simple. Okay. Okay. 1 plus cotangent squared theta is equal to secant squared theta. So 1 minus secant squared theta is equal to negative cotangent squared theta. And tan squared theta plus 1 is equal to secant squared theta. No, why would I do it like that? No, that's not very helpful. Okay, I'll do that later. That can be a later problem. Let's just write it in terms of sine and cosine. I don't know how to play Fortnite. I can't Fortnite game. I can play Tetris and Dr. Mario Tetris. If you want to see me play Dr. Mario Tetris, okay. Fortworm. Okay, I'm gonna write it in terms of sine and cosine. Tan squared x, sine squared x over cosine squared x. Cotangent is cosine squared x over sine squared x. Let's combine those fractions all on the bottom. We're multiplying this one by sine squared x to get it so they have the same base. So you're going to end up with sine to the power 4x. And this one is being multiplied by cosine squared, so you're going to be minus cosine to the power 4x. And this is all over sine squared x times cosine squared x. Now, yeah, question is Miss Ueda. I don't know how to invite Miss Ueda to a live stream. The only reason I did it a live stream because I didn't want to edit doing all 30 of these together because that would be that'd be terrible. That'd be terrible to do. Okay. This is squared. Well, it's to the power 4, and this is to the power 4. When something's to the power 4, it's been squared twice. So it's squared minus squared, difference of squares. We could factor this like a difference of squares. The bottom stays the same. Sine squared x times cosine squared x. Top, let's factor this. Difference of squares. In the first factor, you have the first term, the square root of the first term. So we got sine to the power of 2x. Then you'll have minus the square root of the second term. So cosine squared x. Then the second factor, your first term is square root of the first term. So sine squared x. Then plus square root of the second term. Cosine squared x. Now one of these, sine x squared x plus cosine squared x, that's the Pythagorean identity again. Sine squared theta plus cosine squared theta is equal to 1. So we can replace this way with 1, which basically just kind of gets rid of it. So now we're left with just this stuff on the top, sine squared x minus cosine squared x. I'll erase this now so I have more room. Divide by sine squared x cosine squared x. Sine squared x minus cosine squared x. Divide by sine squared x times cosine squared x. Sine squared x minus cosine squared x. Divide by sine squared x times cosine squared x. Both sides. God. I don't think this one's Zoe. I don't think I'm Zoe. No, still water. Left side equal to right side. Who had said? I'm not gonna respond to that question. Who wants to see question 24? Yippee! Question 24 time. Should I be studying for a midterm? Should I be finishing the rest of my homework? Absolutely. I have so much to do. What am I going to? Infinity Games. Watch out. Be careful. Careful what you say now. This guy will do all my homework. Okay, question 24. It says here that you can solve it in 4, so should be quick. Question 24. Hopefully I can solve these before my pen is dead completely. Okay. Secant of x minus cosine of x, all divided by tangent of x is equal to sine of x. Let's make the table. Right side, sine x. Left side, secant x minus cosine of x divided by tan of x. I don't think we're going to do that side because that side's just sine of x. Yeah, we'll get to the double angle identities. You don't have to pay extra for double angle identities. The last couple questions have double angle identities in them. Right, not quite yet. The last one, technically, we could have done a double angle, but it was just like a waste of time, so nope. Okay, sine x, that's already sine x. We're not going to do anything with that. Over here, we have secant x minus cosine x, all divided by tangent x. Remember, when you write down secant x, don't forget the c. Then you're doing biology instead of math. Okay. What am I going to do? Let's rewrite in terms of sine and cosine. Secant x is equal to 1 divided by cosine x. And cosine x is still cosine x. Then tangent x is sine divided by cosine. Let's multiply by cosine because cosine's in the denominator here and here. So 1 minus cosine squared x divided by, oh, okay, so here's how I did that. 1 divided by cosine x times cosine x, you're going to get 1. Cosine x times cosine x, you're going to get cosine squared x. Then over here, sine x divided by cos x multiplied by cos x, sine x. It's a little hard to see now because my pen is nearly dead. Oh, wow, no, there's so many. There's no. How do I? Yeah, okay, yeah. I don't know how to. I don't have a. I wouldn't want to set up a. I'm not gonna set up a Twitch halfway, most of the way through the stream. I've got 4 questions left. I'm not gonna set up a Twitch now. I don't know how to do that. I don't know how to set up donations. Let's see. Wait. Edit. Customization. Send messages. Yeah, I don't know how to set. I'm not going to give you my social insurance number. No no sin. We're doing sign, not sin. No home address. I'll give you distance from school and no more. But even that is pushing it because this video is available to the entire world. Home address for mailing? I'm not. No mailing address. Okay, let's look at this. 1 minus cosine x. Let's look at the Pythagorean identities again. Sine squared theta plus cosine squared theta is equal to 1. Minus cosine from both sides. Don't say slurs! Sine squared theta is equal to 1 minus cosine. That's cosine squared theta. We got 1 minus cosine squared theta there. We can replace it with sine squared theta. So on top we have sine squared theta, or sine squared x, sorry. And on the bottom, sine of x. We got sine squared divided by sine. What do you get? Sine. Okay. Correct city? Yeah. I'm not giving you my home address. No home address. Left side is equal to right side. Sine of x is equal to sine of x. So left side is equal to right side. I cannot see that left side. Oh my god, this pen. Oh my. Do not buy Quartet pen. Dies after 26 trig proofs. Yes, I know this is at the lowest quality. That's because I'm filming this on a laptop default webcam. No, Quartet will get nothing. And give me nothing. Because I do need to get a better camera. I'm not giving you my IP address! Who wants to see number 26? Yippee! 26 time! This is the one that's, 26 is the one that Seth did, I think. I'm not giving you longitude and latitude! Sigma and Alpha? I'm the Sigma. None of you are the Sigmas. Yeah, I'm the sum of all. Okay, number 26. 1 divided by 1 plus sine of x is equal to secant squared x minus tan over cosine of x. Yeah, you can kind of see what I'm doing. Okay. Table time, left side, 1 plus sine of x. Right side, secant squared minus tan over cos. You can't see what I wrote at all. Cool. Okay. It's secant. Okay. What should I do now? Let's look for any identities. Okay. For funsies, let's multiply by the conjugate. This is 1 plus sine x on the bottom. Let's multiply this by 1 minus sine x. So the top becomes 1 minus sine x because 1 times anything is the thing. And on the bottom, when you multiply, you're going to get 1 minus sine squared x. Now, 1 minus sine squared x, we can replace that by cosine x. So we're going to get 1 minus sine x over cosine x. This is not helpful in any way. Actually, no, it is. Never mind. Sorry, I was wrong. Let's split that into 2 fractions now. So we're going to have 1 over cosine of x minus sine of x over cosine of x. Did I do that correctly? Let me check. Yeah, wait, no, cosine squared. Sorry. Cosine squared. Sorry, it was cosine squared. I will get a better camera sometime. I gotta figure out how to live stream from a GoPro and then also find the GoPro. Or the phone won't let you. I would use my phone because the phone's I got the Samsung. I got the pretty good quality camera. But unfortunately, on mobile, you have to have at least 50 subscribers to stream. So instead, I'm watching the stream on my phone I'm going to subscribe to this. I'm going to subscribe to myself from my other Google account. +1 subscriber, myself. Okay, good job. Thank you. Okay, so now we have 1 divided by cosine squared. 1 divided by cosine is secant. So 1 divided by cosine squared, secant squared. Now, actually, I'll show you on the other side. This side, I'm going to keep it like this. I'm going to change the other side to make it look like that. Secant squared, 1 over cosine squared x. Tangent is equal to sine divided by cosine. You're dividing by that by another cosine. Sine over cosine squared. Can you see that? You can kind of, wait. Yeah. So you got 1 divided by cosine squared minus sine squared over cosine squared. This side, 1 divided by cosine squared minus sine divided by cosine squared. Left side is equal to right side. I'm pretty sure 1 times 1 is equal to 1. Can't be completely sure. I'm not going to prove it, though, because I don't want to do that. You want me to do 50 more? Oh, no, getting 50 subscribers, right? Yeah, that's better, yeah. Okay, who wants to see 28? Why did it take me six steps before? Who wants to see 28? I'm only doing the even questions right now because I already did all the odd numbered questions earlier. Yeah, 28 time. Let's try the other pen. See if you can see the other pen on the page because that pen is invisible now. Oh yeah, that's immediately way better. Okay, number 28. Sine of 2x. Oh, your double angle identities. You can kind of see that. Yeah, you can see that. Divided by cosine of x plus cosine 2x over sine of x is equal to cosecant x. You can read. I'll do 17 right after this, and then, yeah. Did 17 earlier. 17? Was 17? Yeah, 17 was that. That was okay. 17 a little silly. Okay. Table. Not going to put much room on that side because it's right side, cosecant x. Left side, sine 2x divided by cosine x plus cosine 2x over sine x. Let's simplify this to 1 over sine of x. Or not simplify, but 1 to 20. I'm not doing 1 to 20. You can rewind. You can rewind. You can reworm. I'll do 17 again though. Okay, this side. Well, there's only one thing we can change sine of 2x to. Can you see? Yeah, you can see enough. It's very impossible to see this one section though. This one section of the board because it's the lighting. Yeah. I'll do 17 again though. Okay, sine 2x. There's only one thing that's equal to sine of twice an angle or double an angle, it's 2 times sine of the angle times cosine of the angle. And this is still divided by cosine of x over here over sine of x. What should I change cosine to? Here's where it gets tricky, trying to decide what you change it into. 2 sine x plus. I'm going to do 2 sine x for the silly. If you have $1 bajillion, you gotta send me number 31. I don't have number 31. I will do 17, okay? Okay. Cosine of twice an angle is equal to 1 minus 2 times sine of the angle. Sine squared of the angle, sorry. Oh, no bajillion dollars? Oh, too bad. Okay. 1 minus 2 sine squared theta. Okay. I'm going to take this, divide this by cosine, or well, it's already divided by cosine, but 2 times sine times cosine divided by cosine. The cosines cancel out. You can get 2 sine of the angle. And over here, let's separate this into 2 fractions. You got 1 over sine of x, then minus 2 over sine, that's x squared of x, divided by sine of x, which can be simplified to 2 times sine of x. Now, you see here, 2 times sine of x. This is positive. Negative 2 times sine. The same thing. You can cancel these out until you just got 1 over sine x. Let's call that 4 steps. I don't know. I don't know. Yeah, neural networks is just, I don't know. Let's call that 4 steps. Number 30 coming up. Last question. Can you actually? I don't. Rate the streaming setup. How's the streaming setup? Oh, sorry, I forgot to write left side equal to right side. Very important. Yes, Tracy, yes, it's a fair rating. I got a vertical whiteboard in a horizontal screen. The worms are the only good points. The stream is slightly haunted because of the cat painting. It's a fair assessment. Also, the camera quality is, ugh. Yeah, I maxed out on worms. Without the worms. All right, number 30. Cosine to x divided by sine of x is equal to cotangent squared x minus 1 over the cosecant x. Left side, cosine 2x over sine x. Right side, cotangent squared x minus 1 over cosecant x. I'm not a doctor. I can tell you about, let's see here. No. Flatworm reproduction. No DMing minors. No, I'm not a Minecraft YouTuber. Don't. Okay. Oh, look. Something squared. This is probably, and there's a 1. This is, okay, you can't really see it, but 1 cotangent squared x. That's probably going to be a Pythagorean identity. All right. I'll rewrite the bottom here so you can see it a bit better. There you go, a little bit more clear now. Okay. 1 plus cotangent squared theta is equal to cosecant squared theta. If we subtract 2 from both sides, yeah, no, wait, was it? No, that seems stupid. Why would we just subtract? Oh, yeah, might as well. Oh, well. Well. You'll get cotangent squared theta minus 1 is equal to cosecant squared theta minus 2. I'm not sure if that's how you do it. I don't know. Haven't done this in a while. So let's replace this cotangent squared x with cosecant squared x minus 2. The bottom is still cosecant x. Oh, how will we split this into 2? Well, 2 fractions. Well, not 2 fractions. Okay. Cosecant squared divided by cosecant, you're getting cosecant x. Negative 2 divided by cosecant, you're getting 2 over cosecant. Is this a way to solve it? Perhaps. Let's change this into sine. Cosecant is equal to 1 over sine, so cosecant 1 over sine x. Then 2 divided by 1 divided by sine, you're getting 2 sine of x. I'm doing all the questions for fun. For fun. I'm doing this weird. I'm going to do this not like this. I'm going to restart this entire question because I don't like it that I'm doing it this way. Let's start with this side instead. Yeah, I'm going to restart. Okay, yeah. Sine of x. Let's think. No. That's why I didn't want to start this side. Double angle. Cosine of twice an angle can be replaced with 3 different things. So, get variety of what to do. All right. Let's do cosine of twice the angle is equal to cosine squared minus sine squared. Yeah? That's a pen. That is a pen. Okay. cosine squared x minus sine squared x. Now, we have sine x. We want to get to cosine or cosecant x. So, cosecant x is equal to 1 divided by sine x. To get from sine x to 1 divided by sine x, we'll have to divide by sine squared x, this whole side. So let's go cosine squared x over sine squared x minus and sine squared x divided by sine squared x. You're going to get 1. And that's all divided by, so, sine x divided by sine squared x, you're getting 1 over sine x. And then cosine over sine squared. Cosine over sine is cotangent. This is squared, so it's cotangent squared. You're getting cotangent squared x. 1 is 1. Then that is divided by 1 divided by sine. So, and 1 divided by sine is equal to cosecant. So, cosecant x on the bottom. Cotangent squared x minus 1 over cosecant x. Cotangent squared x minus 1 over cosecant x. Left side equal to right side. That's number 30. Yippee! Everyone start making second Google accounts to make more YouTube channels by making more Google accounts. All right. What question do you want to see now? I've done all of them. Show how to inverse a function with okay. Let's write that down. Y is equal to x plus 2 3x minus 1. Much better. Okay. I don't know. Inverse, replace, switch x and y. No. You think I'm doing something wrong, yell at me. Personally, from this step, I would probably expand. Okay. 6y minus y plus 5y minus 2. Oh, divided by. Sorry. Ah! Sorry, I didn't see your little division symbol there. Okay. Redo. Sorry. 3x minus 1. Yeah, get smarter. 1. Sorry about the lighting. Sorry about the awful lighting. Okay, still same thing. X equals y plus 2 over 3y minus 1. Multiply both sides by the bottom to get it out of the denominator. So 3y x minus x equal y plus 2. Okay, give me your homework in a second. I'm gonna look at this one for it. It's usually just moving things back and forth and then dividing until you see like, oh, look, all the y is on one side. Okay. What if I move y over here? 3y x y divide. Oh yeah, that'll be good. Minus y from both sides and add an x to both sides. Then y 3x minus 1 is equal to x plus 2. Divide both sides by 3x minus 1, so y is equal to x plus 2 divided by 3x minus 1. Yeah. Is that clear? Non-alcoholic beverage that I will not name because they get no money from me. No one gets money from me until no one gets free advertising for my 6 viewers. I value you 6 viewers. No one will take advantage of your viewership. Again, okay, fine, I'll show it. Just to prove it's not. I want to prove it's not alcohol, so I'm gonna. It's Pepsi. I just really wanted you to know that I'm not drinking alcohol. Diet caffeine-free Pepsi, the golden. No! No purchase! I have noticed that there's like a 3 or 4 second at least lag between what I'm filming right now and what I'm seeing on the screen. No, more like 10 seconds, honestly, because I can see myself what I was doing like 10, 15 seconds ago on my, because I got the screen on the screen. Subtract y from both sides and add x to both sides, so the negative x goes to the other side and the y goes to the other side. Do not go to my house! No address! No address! Okay, I'm bored. I'm going to do question 23, unless anyone else has has a suggestion. Is equal to tan squared tan squared x times sine squared x. Okay, you cannot see what I wrote there, but it doesn't matter. Okay. Table. Left side, tan squared x minus sine squared x. Right side, tan squared x times sine squared x. Okay. Let's see, there's lots of squares. This could perhaps be a double angle identity, but I would be careful about using those. Because sometimes it's not. I need to review derivatives before I can show you derivatives. Okay. Tan squared theta plus 1 is equal to secant squared theta. So, subtract 1 from both sides. Tan squared theta is equal to secant squared theta minus 1. We can replace this tan squared x with secant squared x minus 1. Now distribute the sine x. Secant is equal to 1 over cosine. So this is really 1 over cosine squared. So, sine squared x. So you're getting sine squared x over cosine squared x minus sine squared x. Now we're here. Tan squared x is sine squared x or cosine squared x. Sine squared x, that's still sine squared x. Not sure why I solved this so terribly earlier, but to know derivatives, you gotta learn limits first. I'm not answering that question. I'm sorry, I'm not gonna answer it. I'm sorry, I will. Holocaust bad, actually. Yeah, Holocaust bad. Bad thing happened. Shouldn't happen again. That'd be bad. No! No deepfake it! Do not deepfake no! No deepfake it! It's AI voice! AI voice! Trigonomic identity. Any other things? I don't know. Let's see if I have my limits things. I've got limits around here somewhere. The worm fell over. Opinions on worm. Worm. Okay. Oh, man. Okay. Does anyone still want to hear about derivatives? I've got the package that Miss Ueda gives out for derivatives, so we could get early edition of derivatives. Okay, I don't know. Derivatives. You know, in physics, when it's like, oh, look, oh, it's accelerating. Oh, that's the speed over time. Oh, look at the acceleration. Find the instantaneous velocity by doing a tangent line. Derivatives are like tangent lines, except you're not drawing you're not having to draw a line. You calculate the line. You instead of sciencing the line, you math the line. Okay, I'll do reciprocal functions instead. But really, that's what derivatives are. You like derive the tangent or whatever. I don't know. I guess I'll be prepared by preparing other people. Okay, reciprocal functions. Let me whip out the reciprocal functions. Okay. No, here it is. Okay, like what specifically about reciprocal functions? You can you can promote this to whoever you want. More subs. Okay, you want that one? Yeah. Okay, generally speaking, first off, reciprocal function. Let's say that's your function. The reciprocal is the reciprocal of that. Crazy, I know? It's 1 over f of x. Yeah? Okay. So for that one specifically, y is equal to 1 divided by 4. Okay. Is that the original function or the reciprocal? Okay? You gotta give me a little squared minus 5x minus 6. Well, okay, can you tell me if that's the reciprocal already or no? Sorry. 5. Is this one the reciprocal or is it the original function? I need to know so I can actually solve the question. Well, either way, complete the square time. Oh, yeah, well, you have to, okay. You gotta figure out the bottom function, like how you graph the bottom function first. Circles. Take some points. Well, anytime it's going to be equal to 0, asymptote. Because 1 divided by 0, kinetic equilibrium. I know static equilibrium because Mr. Grassi is slow. Asymptote. I'm going to erase this other stuff. As you get here, the number gets smaller and smaller. It's positive, so you're above the line, you're above the x-axis, and so, over here it's starting out like really big, so 1 divided by a really big number, you're getting a really small number. But once you get over here, it's still positive, but it's 1 divided by a really, really small number, so you're going up. Same thing on the other side, but we are, static. Yeah, I'll do static in a second. Okay. Now on the bottom, it's negative, so you're going to be, the graph again will be negative, unless you have, this was also an absolute value and a reciprocal, but I don't think it's going to happen. Okay. Divided by a very small number, you're going to get a very big number. Divided by a very small number, you're going to get does anyone want to see my cat? Oh, no, he's leaving. Okay. Where it's divided by, bigger number, you get smaller number. Okay, let me pull out whip out the cat. Nelson, get right here. Cat reveal. He doesn't like being picked up. Okay. What do you want to know now? Static equilibrium? Okay. Can you give me an example, or like what specifically about static equilibrium do you want to know? Right now, I personally prefer to do. If you want to be an alpha, you gotta be mean to women. Okay. I don't know. I'm a sigma, not an alpha. I can tell you how to be an alpha. Okay, static equilibrium. Let's go over the conditions of static equilibrium. First condition is when you're looking for translational equilibrium. So it's not objects not moving backwards, forwards, left, right, up, down. It's not doing any of that. It is still translationally. Zero. No, don't clip it. Okay. First condition, to have that static equilibrium, or the static translational, the sum, the sigma force, we're talking about sigmas now, is equal to 0. Sum of all forces is equal to 0. And now there's a second condition of static equilibrium, the rotational equilibrium. So, something could be moving like back and forth, side to side, but you want to know, is it rotating? The rotational equilibrium, like this worm may be in static equilibrium, but if it rotate, it just rotated right now. Technically, it was static translational, but rotationally not. And for it to be in static rotational equilibrium, you have to fulfill the second condition. Sum or sigma torque is equal to 0. Okay. Everyone's good with this? Okay, moving on. If you don't know torque, here's how you do torque. So let's say you have a worm. You have a worm here. You can calculate the torque of the worm if, say, from the force of gravity, like say this, what's the torque on the worm right here? If this worm was a solid object, what's the torque on the worm? So you calculate torque you take torque is equal to the lever arm length times the force. So the force here is the force of gravity, because that's the only force acting on the worm. And force of gravity happens you measure force of gravity from the center of mass, like center of gravity. So that'd be like center wormish. And also the lever arm length is not like the whole length of the object or the beam. It's just the length from the pivot point, where it's the point that's not moving, to where the force is being acted on. So half worm. So torque worm is equal to the length of one half worm in meters times force gravity worm. For this, you always have to measure in meters, and in force is always in newtons, because torque is in Newton meters or foot pounds. Okay. I know it's going to be like 20 seconds before anyone responds to this question, but is there anything else specifically you want to know? Technically, you could also write, because a Newton is kilogram meter per second squared, a Newton meter is equal to a kilogram meter squared per second squared. I don't know how to make meth yet. You gotta get chemistry 12 at least before you can start making meth. Unless you're Jesse Pinkman, who apparently didn't do well. Eisenworm. Walter Worm. Wormy, we need to cook. Anything else? Anyone else? I sleep. I don't know. After you guys go to sleep, I should be asleep by now. Like I promised, I wouldn't go to bed later than 10 o'clock, but clearly that didn't work out. All right. What unit of math do you need help with now? What do you need to study for the midterm? Addition. Well, I don't want to do addition. Worm plus worm equal 2. I'm gonna do multiplication. You're gonna learn multiplication now. I'm gonna make you do times. Make your own times table to follow along with at home. Here's something they don't teach you about times tables. You can cheat at them. You don't have to know all your times tables to complete a times table. You can count how many boxes in the square. So if you have, say, 3 times 2, you can be like, okay, this is my space. 1, 2, 3, 4, 5, 6. 6. It's 3 times 2 is 6. 4 times 4. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. 8. 9, 10, 11, 12, 13, 14, 15, 16. 16. It's just really efficient to do, inefficient to do it like that. Estimate 1 minus 1. 0-ish. Short division. Okay. Medium division. I can show you guys how to multiply decimals. Okay. 45 to the power of 5 times... I'm not doing that. No balls, fine. Okay. We get 9, 5. 2, 10. 97. Does 97 have any factors? Let me pull out the calc. 97 has no, like, factors. 97. '97 has no factors. I'm just trying to find factors in 97. Oh, Jesus Christ. Okay. Fine. Multiplying by 97 again. This is that to the power of 2. This will be to the power of 3 over here. I will do it. You can't stop me. Okay. 7. So you're going to get 63, 28. Let's erase that. 63, 20, 90, 81, 4 times 9, 36, then 2, 1, 1, 9. Okay. 9, 1, 2, 6, 9, 1, 2, 6, 7, 3, or 4. Okay. Multiplying. This is the fourth power now. Gotta multiply by 90 now. Okay. 3 times 90. 270. 7. You're getting 63 over here. 90. Getting 54. 90. 18. 9. 81. Okay. 1. Eight plus 4. So 2, 9, 1. Okay. 15 plus 2. 15 plus 5 plus 2, sorry. That's 97 to the power of 4. Please don't dox me. Okay. 8, 5, 2, 9, 2, 8, 1. I have no idea if I'm doing this correctly because I don't have the calculator. This is it to the power of 5 now. Okay. Multiply by 7. 7, 56, 14, 63, 14, 35, 56, 56. Now multiply by 90, sorry. You're getting 9, 72. So one's place is going to be 1 over. 2 times 9, 18. 9 times 9, 81. 2 times 9, 18 again. 5 times 9, 45. 8 times 5, 72. 72. How do you like that, huh? Okay. 2, 1. 8 plus 7, 15. 3 plus 1 plus 1, 5. So you're getting 20 there. 8 plus 8 is 16. 16 plus 5 is 21. 21 plus 1 plus 1, 23. 5 plus, okay, 6 plus 3 plus 1, that's 10. 17. Okay. 1 plus 2 plus 5, you're getting 8. And the 4 plus 6 equals 10. Jesus. 1 plus 2 plus 7 equals 9 is 10. 5, 8. It's 23 did it. Okay, goddamn it. Oh my god. Let's get to the power of 6 now. Let's hope I remembered how to do this. 14, 0, 0. 28, 21, 49, 56, 35, 56. Multiply by 90, 63, 45, 18, 0, 36, 27, 10 times 9, 30, 63, 32, 45, 72, 7, 1. Okay. Not sure. No. Who texted me? Okay, I've definitely got to go soon. Does anyone have actually any relevant math they want to know about? Because I should. Midterm tomorrow. I will multiply this one more time, though. I will get to power of 7. I'm not sure if I will multiply by the other numbers. I don't want to do that. I don't want to get to the 23 digits. This is a very annoying process. This will be to the power of 7 now. Not sleep streaming. No sleep stream. Okay, 7 times 9, 16, 14, 63, 28, 14, 49, 63, 14, 21, 56. Multiply by 9, 81, 18, 81, 36, 18, 0, 0, 18, 63, 81, 18, 27, 56, 3, 1, carry over the 1, 1, carry over 2, 8, 1, 7, 4, 4, 8, 2, for the 1, 8, carry over 1, 9, carry over 1. That should be 97 to the power of 7. I don't want. Okay, yeah. Let me help out Mr. Beast. Yeah. Gonna boost a small little channel like Mr. Beast. Yep. Thank you for the suggestion, Entity Games. Very helpful. I'm not doing any more with this number. I'm gonna check. I will check though if that is in fact 97 to the power of 7. I was wrong. I did it wrong. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did it wrong. I don't want to do that. I'm not multiplying big number anymore. No more big number. Goodbye, big number. I messed up somewhere. If I had it all written down, I could check where I messed up, but yeah. No one has any more math they want to see before stream end. Then stream end. Anyone want to see Big Worm one more time? I'm no, but you want to watch? You want to watch a miner sleep? Someone investigate. The worm. Goody goody goo. Wormy wormy worm. I'm an evil villain with my. No. Okay, I guess just the worm sleeping, that would make sense. Maybe not tonight though. If the midterm goes well, we get the worm sleep stream. Okay. Yeah. Everyone passed the midterm. We get the worm sleep stream. I'll reward you with worm. The worm you'll have 12-hour of worm. All right. No worm only fans. This worm is only 1 year old. This worm is a minor worm. No cat only fans. Bit old. Sorry about that. No cat. Yeah, redact that. Absolutely redact that. Yeah, maybe. It's got clothes on. That means it can become nude. All right. Absolutely no more math you want to see done? You don't want to see any trig? Any conics? Any wormics? You know, we went over a lot this year. We had wormic sections, trigonometry. Now we're doing worm proofs. Do you want to see a little wormics? Okay, I gotta fix up the setup's about to die. Okay. Wormic section. So here, you got your 3D shape. You got your wormic. It's like two cones, kind of. And, you can take sections of these. You can take, like, little slices of it. You can take a slice here. You can take, like, a slice there. This one's parallel to it. Why don't you take a slice straight across there, or a slice, like, just at a bit of an angle. So not parallel to it. All these make different wormic sections. Wormic section, because it's a section of the worm. The wormic. Yeah, I gotta sleep for the midworm. Just a sec though. So start off, if the slice is parallel to the side of the wormic, then you're going to get a paraworm. Or possibly negative paraworm. Then, if yours is not quite, it's not parallel, but it's at an angle, well, first off, if it's straight across, wormhole. But if it's not quite straight across, if it's kind of at an angle there, you worms. Then, let's say you have the one straight down there, like you're gonna get. Let me pull it out. It's gotta show it on a surface. Hyperworm. Wormix. Yeah. All right, that's probably enough Mathowormix for today. We went over Trig Proofs, Wormix sections. We've done a little bit of multiple wormtion. So I think we're good. You ever find some good? No. Mm-mm. No worm in it. Don't worm it to the worms. They don't consent. They don't no consent. Yeah, that's after that, that's good. No more. Good night. Good wormed.